chemical known as methyl isocyanate. But actually, chemical is not responsible. That is the theme of my speech today. It is some kind of negligence. Somebody didn't check something properly. That is why the chemical leak and accident was caused. If all taken, what we know about in chemical engineering term, we call it as hazard and operability study, HAZOP. If HAZOP study was properly done, there will not be any accident. And Bhopal was a starting point for the entire world, because before Bhopal, nobody in industry, nobody in colleges, nobody in the world was really geared up to handle accidents, or the education for safety was not at all taken care.
Excuse
There
me,
were
sir.
no officers appointed. Pardon?
Sir,
Yeah.
sir, can you click on slideshow, please?
Okay. Okay, is it okay now?
No, sir. Sir, actually, sir, the taskbar, there is one icon called slideshow.
Yeah, I clicked that, and at least on my computer it is,
Okay.
I see taskbar of the video conference.
Yes, sir. Okay.
Okay, just a minute.
Okay. Sir, sir, in the PPT, I think.
Yeah.
Okay, madam, are you there?
I'm sharing
yes,
my presentation.
Yes, ma'am. Can you please guide, sir?
Sir, there is a small icon here.
Yeah, icon
at the
of
bottom.
slideshow, right?
Yes. So just
a slideshow in my PowerPoint presentation, or icon in the
your PowerPoint presentation, sir.
Yeah, that I clicked, but he says it is not visible. I'll click it once again, and you tell me if it is visible. Is it visible now? Is it visible?
It's visible, but it's not going to the slideshow. It's okay, sir. Please continue.
Then what is visible? At least in my computer, it is showing slideshow. I'm surprised.
Okay.
Is it now? Is it showing?
No problem, sir.
No problem, sir. Please continue. Yes.
Please continue, sir.
Okay. But is there anything, because I clicked the icon of slideshow, and at least on my laptop it is showing slideshow to me.
Yeah, sorry for the disturbance, sir. Please continue.
Okay, no. If there is a problem, not able to tell me frankly, I will try something else. Okay, fine. If you are able to see, then it's okay. Huh? Yeah.
Yeah, it's visible. Okay, yes.
Okay. So,
you could just zoom in, and sir, you could just zoom and increase the power of it, if that is possible.
Zoom and increase the power.
Yeah, on the bottom right-hand side, if you can see that. Otherwise, no problem. Go ahead.
This is what you mean?
No, it's not happening. No, sir. Continue, please, sir. Don't worry. Yeah, that's it. That's great.
Yes. It's
youngsters are very techno savvy, so I'm taking help from my son. Just a minute. Give me a. They are not able to see the slideshow in a big format. They are just able to see only small things. I am familiar with the Zoom, but Google, I hardly, maybe a couple of times I gave presentation. Zoom, even almost daily I am giving. Zoom, okay. No, this will only increase the percentage. Just give me a second.
Full slide.
Huh?
Full slide you want.
But this is the full slide here. Are you able to read what you have written?
Yes, but it's gone to okay.
Very small.
Right.
It is very small.
So in this mode, you can try the slideshow icon, the word again.
Okay,
Here.
slideshow icon.
Right,
Yeah,
try
just a
that.
minute. That I tried a couple of times, but you said
No.
it is not visible.
Right
Okay,
now
now
you
it is
could try.
slideshow.
Mm,
I have tried. Is it visible?
no.
No, I guess not.
No, sir, it's okay. Please continue, sir.
Okay, you are able to read Bhopal
Yes,
on 3rd
perfectly. Yeah.
December? Okay, fine. Okay, this is first time it is happening. Even I think Google also have given couple of presentations in the last 1 year, but this is first time it is happening. Zoom, yes, every day, almost every day I give some lecture somewhere. But anyway, if there is a problem, let me know. Okay, so Bhopal accident was a turning point, and everybody became conscious about safety. And this was something which just give me a minute. I will see if I can do something else. Otherwise, I'll come back to this mode. No, I think this is the best I can do at the moment. Okay, I will continue with the way I'm. Fine. So after Bhopal, everybody woke up to the situation. Chemical industries, governments made lot of rules. Each chemical industry, it was mandatory to appoint a person as a safety officer. Everybody started doing something in advance before doing any reactions, before setting up any plant. And this totally changed the situation. Even in India, all the industries, all colleges, all institutions became safety conscious, and they have remained so. So accidents is a cultural and attitudinal problem, and it is not a chemical problem. Safety is nothing but common sense, because accidents happen because of culture. I'll give you an example. In year 2000, we took over another company which was even older than us. I don't want to name the company, but that company didn't have the safety culture the way we had it. And this company, when the people started working with us, we realized in the first fortnight itself that there were many more accidents. I personally realized the research people who joined under me in our R&D center from this new company, in almost 20-25 years, there were no accidents. But within 2 weeks, I started having accidents in our laboratory and pilot plant and manufacturing site. This was very alarming. We realized that this is because safety culture that is required was probably not developed in this company that we took. So we paid extra attention to this fact, and the culture was changed to suit our culture, and then all the accidents stopped. So accidents is a cultural and attitudinal problem and not a chemical problem. So the motto of every person, whether he is a student or professor or principal, director, the motto should be nil accidents. Never say that I will try to make sure that there are no accidents. When you say I will try, there is a small probability of 0.1 or 1% that there may be accident. But always say my motto is to have nil accidents, absolutely 0% accident. That should be the motto. Safety is everyone's responsibility. Safety is not only principal's responsibility or professor's responsibility or lab assistant's responsibility. It is everyone's joint responsibility. And then only safety works. In an industry, right from managing director, chairman, up to the lowest worker, it is the responsibility of everybody. And that should be the culture. Inculcating desired culture in the organization is the responsibility of the topmost boss. Topmost boss is responsible for inculcating the desired culture in the organization. Now I'm coming to the most common accidents. Are you able to see this picture? Is this picture visible?
Yes, sir. Yes,
Okay.
yes, sir. Yes.
Okay. This is the most common accident world over, whether it is laboratory or hospital. What is this accident? When you are trying to insert a glass tube in a rubber tube or rubber cork, the glass tube invariably breaks, and the amount of injury that you have to your both palms is horrific. I know at least a dozen accidents where the people were severely injured, lot of blood loss, and several stitches had to be put on the left hand index finger, right hand index finger, and left and right hand thumbs. Because the mistake that we make in inserting the glass tube in a rubber tube, there are several mistakes. Just remember this permanently. The mistake number one, whenever we are trying to do this operation, these operations require lot of pressure. When you are putting a pressure on a glass tube or glass dropper, never use ordinary glass tube or glass dropper. Use only borosilicate. That means in India, there are certain company like Borosil. In Western countries, there is a company called Corning, which has a special glass, and use that glass, tubes made up of that glass, so that they are sturdier compared to ordinary the cheap droppers or cheap tubes what you get. So this is a very important precaution number one. Precaution number two, when you are exerting pressure to insert the glass tube in a rubber tube or rubber cork, make sure that you are holding the glass tube very close to the rubber tube. Don't hold it 3 inches away or 4 inches away, because then you know the physics principle. The tube will break when you exert so much pressure, and it will break in such a haphazard manner that it will, with the pressure that you are putting, it will directly go in your fingers. So exert a pressure very near the joint where you want to insert, very near the rubber tube, you have to exert the pressure. Point number three, always use thick leather, or there are some very thick gloves available in the market which are not rubber gloves. Rubber gloves can be torn easily with cut glass, but there are some very thick synthetic gloves available, about 2 millimeter thick gloves, and these are available in chemical shops, and those gloves have to be used. Thick leather gloves or thick asbestos gloves, or there are some thick synthetic gloves which have to be used. If you take these precautions, you will never ever have the cuts because of this. And since this accident is the number one accident in chemistry labs and hospitals, utmost precautions have to be taken, because the results are, if you don't take these precautions, lot of blood loss, stitches, and injury for several months is there. I know people who lost sensation to their fingers because even nerves were cut in such accidents, and lifelong they lost sensation. Remember, in certain country, America, they had to perform neurosurgery on the finger nerves so that the nerve get the sensation back. But at India, this is so easy. At least in smaller places, it not be feasible. There, I know in America and Germany, doctors known as finger specialists. The specialty is only fingers, and they can perform these surgeries under microscope. But I think every place it is not available. So better think to take precautions. That at top, I am showing those gloves. These gloves which are on the top are very thick and they can be used. The other gloves which are orange colored, these are known as butyl rubber gloves. They can be used for handling chemicals, liquid chemicals. Many times are known as the surgical gloves, which people wear during Corona pandemic, so that they don't get touched by foreign things when they touch anything, any surfaces. So those gloves are useful only for other, like for doctors only. These are disposable gloves and not good for solvents and chemicals. The top gloves are good for thermal. There are even better gloves for thermal purpose. If you are using a crucible at 800 degrees, 900 degrees, if you are lifting, then there are asbestos gloves available. So such gloves should be stacked in laboratories. Another most common accident involving hands is heating a beaker containing flammable solvent on burner. This mistake should never be done. Never heat solvent on a flame. Never heat solvent open or open a heating mantle. Always use heating material like hot plate. Sorry, not hot plate. Hot plate also should not be used. Use oil bath or water bath. There are various methods to heat. Suppose if you want to heat below 100 degrees, use water bath. If you want to heat up to 160, 200 degrees, 160 or so, use normal oil bath. If you want to heat up to 200, 250, use silicone oil bath. Beyond that, if you want to increase temperature and if the system is closed, maybe you can use hot either heating mantle or heating jacket. And if you want to heat at much higher temperature, above 300, there is something known as Wood's metal. This is a very inert metal. This melts above a certain 70 or 80 degrees temperature, and there is no question of catching fire or anything. So use Wood's metal for something if you want to heat beyond 300 degrees, beyond 250 degrees. Now, another very common, the second most common accident is involved when you are sucking liquids using a pipette. Never suck with your mouth. This is not Pepsi Cola or Coca-Cola to suck using your mouth. Always use a rubber bulb. It only costs 5 rupees, 10 rupees. Bulb, even smaller and cheaper rubber bulbs, disposable rubber bulbs are also available. Use those rubber bulbs, or there are calibrated pipettes available, which are plastic pipettes with automatic pipetting game. Those are little expensive, but if you want to use ordinary glass pipette, then use rubber, but never use your mouth. I have seen many accidents where people suck various chemicals, or even in microbiology lab, they suck bacterial samples. So never do that. So this is the second largest accident world over. The third most common accident world over is involving eyes. In India, unfortunately, the practice of using safety glasses or safety goggles is not there. This should be started. Safety goggles without number hardly cost, the cheapest one costs even 300 rupees, 400 rupees. And the one with numbers will cost maximum 700, 800, 1000 rupees. So we have to buy these safety glasses with side shield so that even if there is some spillage, nothing enters your eyes. When I went to United States in 1980 to do my PhD, it was compulsory in our university to wear safety glasses. See, the practice of using safety glasses comes only by compulsion. If you just request people, hey, please do, they will not listen to you. They will give hundreds of excuses that it is fogging, I'm not used to it, I'm not able to see. But if you make it compulsory, people slowly get accustomed to it. I'm so used to it for last 41 years that I can't enter a laboratory without safety goggles. I feel very uneasy, as if there are no clothes on my body. It is so uneasy feeling. So safety glasses is just a matter of compulsion. In my university, the rule was if you are caught once, you get a warning. If you are caught once, you are out. No mercy. Same thing in various multinational companies where I have worked. We had similarly very strict rules that safety glasses are a must. We used to have posters everywhere and lot of compulsion. Even in some industries, there was a rule that if you are caught without glasses, your salary is cut for that month. Unless you have such harsh measures, people will not get used to it. Why I'm telling? Because I have witnessed several accidents involving eyes, and people were not wearing safety glasses. I remember one person who was very senior to me, and he came back with his PhD from America and started working in our multinational corporation in India, in Mumbai. This I'm talking about incidents of, I think, 1980s, early 80s. And this person was working in a laboratory, in a research laboratory, and something spilled in his eyes. This was all pre-Bhopal days. So people were not so concerned about safety. Even the companies, multinational companies, were also not very concerned. So he was doing a reaction without safety glasses, and something spilled in his eyes, and his life was ruined. Believe me, his life was ruined. This person is still alive. He is in his 70s, but he is not totally blind, but there is a sort of formation of a membrane on his eyes, and every few months some operation has to be undertaken. Since he was working for a very large company, they sent him to America. He had several operations done, but nothing improved. He could not get married. He could not get a job. Only thing he can do is go to library and just read for few hours. He cannot read at a stage for a long time also, and his life is ruined. He got a job to do some literature search, some jobs here and there. The company where he was working, they supported him for some time, conducted many operations, but once it became irreversible, even they had to release him. I know one more case. There was a person, he was working for a polymer company in, I think, central area of India. I don't want to name the state. And he had hydrochloric acid reaction going on, and hydrochloric acid spurted in his eyes, and he lost his eyesight for all practical purposes. Only thing what he can do is read large, big size, bold, the main big news in the newspaper. Other than that, he can't read anything. He can walk around, but he can't even cross a road with confidence. So I know these two incidences. I've seen one more incident, but these are the severe incidences I see. Eyes is something which cannot be replaced. So be very careful. 300, 500, 1,000 rupees goggles will save you for lifetime. So remember this, take it very seriously. This is the world's number 3 accident after hands, mouth, eyes. So basically, the protective equipment is a must. Safety goggles, mask, depending upon what you are handling. If you are handling powder, then only a mask like this girl is wearing. Then if you are working in some pharmaceutical company with some steroids or something, then you have headgear, then gloves, face mask, and if you are working with some special chemicals, then mask with the canisters. So when Corona started, for me this was not new. I'm already used to wearing face shield, because almost 40, 41 years I was wearing face shield in the laboratory. Mask is not new to me. Even I'm used to wearing steel coated shoes. So even if the brick or stone falls on my legs, nothing happens to it. So with Corona, there was nothing new for me to wear the safety protective equipment. I think this practice is a must in laboratory, this safety equipment. Another very important precaution, there are certain ways we should wear safety equipment. For example, when helmet has to be worn, there is a chin strap which has to be tied under the chin. Or if there is a scooter or motorcycle type of helmet, it has to be properly fixed on your chin. It should not be just kept on your head. Why? I'll tell you, I have seen in our company, I had seen only one fatal accident. It was not because of chemicals. That's why I said chemicals are not the cause of accident. It is the negligence that causes the accident. So this particular worker was operating a forklift. You know, forklift is something which is used to take drums from one place to another. It's a sort of a small car which carries drums, and it went on a slope and it got toppled. As per rule, he was wearing a helmet, but he had not put the chin strap under his chin. So as the forklift tilted and fell down, the helmet was thrown away, and all the drums and the forklift fell on his head. His head was smashed and on the spot died. I know another young professor. She was a professor of zoology in a college around Mumbai and outskirts of Mumbai, a friend of my wife, and she was riding a scooter and not wearing the proper type of well helmet. She fell down, her head was stuck against the divider, and she died on the spot. So always remember, the safety equipment should be of a standard type, should not be purchased on the roadside, and whatever precautions are there, like putting a chin strap, etc., has to be worn. This person lost his life just because negligence not to wear the chin strap. So remember this. Another most common accident with respect to chemicals is sodium metal. Sodium metal is the worst possible cause of accidents in industry, in teaching institutes, in research laboratories. I know at least several accidents which were caused because of sodium. The first accident I remember happened in one college. One girl was doing one reaction. I mean, undergraduate girl. So there is a sodium fusion test. So, you have to cut sodium with a spatula on a filter paper. Then you put the sodium pieces in the small tube. And most important precautions, usually the lab assistants as well as students forget. The filter paper, what they use for cutting sodium, is just left unattended without quenching. That mistake should never ever be done. She put the filter paper in the reaction tube and then she turned around to chat with her friend. She had long hair. As she was turning around and she was chatting with her friend, the kerosene on the filter paper evaporated. Filter paper, the small particles of sodium, what was there, they caught fire, and her hair also caught fire. This incident happened before Bhopal, so nobody was conscious about safety. So there were two safety fire cylinders, extinguishers on that floor. But when the college was constructed, the extinguishers were purchased. Nobody had done any oiling or whatever, taken care of those extinguishers. When people tried to use those fire extinguishers, none of them worked and her hair continued to burn. Very unfortunate incidents. So we learned two things from this. Never keep the filter paper after cutting sodium just like that on the table. It has to be quenched properly. How it is to be quenched? First, it has to be dipped in a higher alcohol, like propyl alcohol or butyl alcohol, and then put in water. Why alcohol first? Because suppose if you have slightly bigger pieces of sodium, it will catch fire then and there itself. So first, convert it into the derivative of butyl or propyl, and then put it in water so that the intensity of reaction is reduced. Another incident I remember in my IIT days, after third year, we had an industrial training. I worked in one very big industry. It was a privately owned industry, and one day a circular came that the owner of the industry was supposed to visit next day. Everybody is aware, whenever there is an inspection, what we do? We immediately start cleaning, keep everything under the sink, and make sure that the table and the racks are very clean. Same thing started, right from the head of the laboratory to Pune, and we all trainees, we were on the job to clean everything. Make sure that there are no unlabeled bottles. Whatever is lying there which is not really required, throw it under the sink. The execution started. One Pune opened one bottle. The bottle was unlabeled because the label had come out because it was very soggy bottle. And inside the bottle, there was nothing really visible. Only at the bottom of the bottle there was something like a slimy material, something like a mud. So he thought it is something waste product, so he dumped it down the sink. My God, the laboratory was on the third floor and the bottle had small pieces of sodium, and the sodium went down the drain all the way up to ground floor. And those days there were no plastic pipes, it was all metal pipes. Everywhere, every floor there was like a bomb blast and pipes blasted, and there was a horrible thing which could not be rectified till the owner came next day. And this is the lesson we learned from sodium. I remember in my PhD days in United States, one Friday evening, once I was going up in the laboratory, I took a lift. I was waiting for the lift to come, and opposite lift there was a lab on the ground floor. I could smell something and I could see some smoke. As a PhD student, we used to have master keys of all the laboratories. I opened the lab. It was a Friday late evening, so everybody has gone home for the long weekend. I was the only person in the building. I opened the lab and found that the dustbin had caught fire. I immediately called the lady who was in charge of that laboratory, the student, PhD student. She said, I said, what happened? There is the dustbin has caught fire. What did you do before you left? She said, I used sodium and threw the papers in the waste paper basket. Never do this mistake. Always quench the sodium used papers, petri dish, spatula, knife, everything with alcohol followed by water. Even the hood or table also should be properly sprinkled with water, so even small particles of sodium are quenched. Otherwise, this is the most dangerous thing. I remember when I was working in one small industry, my second job in India, I went to a very, very small toll converter. They were using sodium bricks in a big reactor containing THF, and they were just throwing. My God, it was very hot afternoon. The person was perspirating, and I was scared to even stand there. If even one drop of the perspiration would have fallen in that reactor on the brick of the sodium, the entire building would have caught fire. I immediately stopped him and told him what is safety. So make sure that sodium is taken care properly. The next important thing is fire extinguisher. We just now talked about fire extinguisher because fire extinguisher proper maintenance is very important. Every 3 months, fire extinguisher should be maintained. There are service providers available. Service contract can be given. Make sure that fire extinguisher is properly maintained. Value should be checked depending on which fire extinguisher it is, whether it is filled, etc., etc., whether it is working, whether the lever is not jammed, not rusted, and give this service contract. It will cost little bit money, but it will save life. And how to make sure that it was maintained? A label should be put on the fire extinguisher. We had a practice in our industry that I had started this practice that suppose today on 18th of July, I am maintaining a fire extinguisher. After maintenance, I will put a label that the next inspection is due on August, September, October. So 18th of October, the next inspection and maintenance due. So moment somebody reads this label after 18th of October, he knows that it is not maintained. He will remind you that it is not maintained. So for every periodic jobs, whether it is maintenance of fire extinguisher, maintenance of lab balance or anything, the fire alarm, everything, whatever is there in the safety shower, safety eye wash fountain, everywhere the label has to be there. Next maintenance is due on such and such day. And that is the must. The head of the department or the principal of the college must make sure that such labels are there. Even for storerooms, there should be a label. The next maintenance of this storeroom is due on such and such day. We used to have practice that every Friday evening before leaving, half an hour should be spent by every person, right from head of the department to the lowest peon. He should spend half an hour in the laboratories and storeroom to make sure that everything is kept properly. If you leave it for inspection day, it never happens. Also, every 6 months, external inspection should be done. I go to many colleges and institutes and industry to conduct external inspection, because whatever you see every day, you may not find anything unsafe there. But a third eye, person coming from outside, he will immediately find out something is wrong, this is wrong, that is wrong. He will point out. He will come out with a list of unsafe things, and those unsafe things should be rectified within next 6 months. That is the way the external inspection should be there. Another thing is a safety shower and eye wash fountain. You don't have to buy a very fancy safety shower or eye wash fountain from Aldrich catalog or something. Have an ordinary shower at outside your veranda, in the corridor, outside your laboratories. There can be one common shower for all floor, entire floor, and one eye wash fountain. So in case something is spilled in your eyes, immediately eyes can be washed for at least 15 minutes. And if something is spilled on your body, you should get a bath immediately. This is a must. I have seen many accidents where it was necessary. Don't think it is something fancy. No, it is necessary in case of emergency. It is really required. Now I'm telling you certain simple precautions which avoid accidents. If you are holding a 5-liter bottle like this, or even small, half a liter, 1 liter bottle, totally wrong. Never hold a bottle with a neck, because neck is a very weak joint of any bottle. So always have one hand on the neck of the bottle, another hand should be at the bottom of the bottle, and with 2 hands you should properly hold the bottle and take it, so that there is no accident. With such kind of lifting as I shown in the photograph, I know there were at least 1 or 2 accidents in some institutes where the bottle broke down and fell on the feet, and there was serious problem. This is what is known as a separatory funnel. You all must be using right from the undergraduate laboratories. It is used to separate 2 liquids from each other. Usually one of the liquid is a solvent. Then there is a stopper is put, the liquids are shaken, and there are certain precautions. Precaution number 1, you should, if the stopcock is not a plastic one, if it is a glass one, it should be greased properly. Otherwise there is a leakage, and if you are handling any corrosive liquid, it will damage your hands or it will fall on your legs. If there is no greasing, there is a leakage. Same thing with the stopper, it should be greased. That is precaution number 1. Precaution number 2, you should vent. After you shake, you should vent so that the pressure is not built up inside. Precaution number 3, when you are venting, don't vent out opposite, stand near your table and face the tip of the separatory funnel to the opposite table, because somebody may be working there. So go near a wall, vent it by pointing the tip towards the wall. These 3 precautions are absolutely must for separatory funnel. Share accident findings and constantly teach the lessons learned from accidents. This is very important. Share it with other colleges, share it with other universities, share it with other industries. In industry, we had a practice. We used to share all these things with other people so that others don't have accident. There is no secret. There is nothing to be ashamed about accident or near-miss accidents. We used to share it with everybody. There are certain sites where people share accidents on internet. Reporting of accidents is very important. Don't hide accidents. Create a culture in your laboratory that everything is reported very freely. So number 1 rule is no punishment for accident. Never ever punish anybody for accident. Never ever say, hey, what did you do? No. Encourage people to report accidents. Then only accidents will reduce. In the beginning, I told you about we took over one company. What I did is I followed these rules. They were very scared to report accidents. I gave them comfort. I said, report Even if you are pierced by a small capillary, even if there is a drop of blood, report it. Even if there is no accident, but you feel there would have been any accident if I had not done this way, report it. Once you report the accident, immediately corrective and preventive action should be decided, and this should be circulated to everybody concerned. So that accident never ever reports in your company or your college or even the surrounding colleges. We used to follow this practice very strictly. So in 26 years that I worked in one company, I didn't have a single accident under me, even though we handled every known dangerous chemical on a ton lot. We handled cyanide on drum scales, we handled oleum, concentrated sulfuric acid, phenol, you name any chemical, we handled it. We developed processes for it, but not a single accident. I'm very proud because we had developed this culture inside the company. And this should be the culture in your colleges also. Then there will not be any accident. And always remember, I will not have any accident. Not that I will try not to have accident. Never try. Will not have should be the wording. Okay. Periodic follow-up on the audit also is very important. What are the good laboratory practices? Make sure that everyone has the nails cut, because many chemicals or even bacterial microbiological samples get adhered inside the nails. Hands should be properly washed. In fact, before Corona, we knew all these practices. So for Corona, it was not very difficult. Any good chemist will not have any fear about the Corona practices of safety. Hand washing. Then ovens and refrigerators should be used only for reactions or, laboratory purpose, not for making a birthday cake or not for keeping ice cream. Daily close down procedure should be written down on the door, inside the door. So last person leaving should tick mark on the each entry of the procedure. Okay, I have made sure that all the switches are off. I have made sure that the air is off. I have made sure that the hydrogen is off. I have made sure that blah, blah, blah. He should tick mark and sign before locking the door. Emergency procedure should be written in a bold letters inside the laboratory. A poster should be made and everybody should be aware what is the emergency procedure, what to do, where to take a safety shower, where to gather in case of fire, etc., etc. There should be weekly audit. As I said, every Friday evening, half an hour weekly audit where the topmost person is involved. The head of the department must be involved. Don't leave it to only peons. Hey, you do it and just tick mark. No, should be taken very, safety must be taken very seriously. I had a practice that anything before making sure that it is safe, we never used to handle any new reactions, new projects, nothing. I never accepted any new project, no matter how much money was given, unless I am absolutely sure about safety. Even small cuts on the farms should be taken very seriously. Don't allow the person to work in the laboratory if he has a cuts on his palm, his or her palms. Never eat in a laboratory. People have a habit, but I know many accidents, many poisoning cases because of eating inside the laboratory. The nails which look like this photograph should never be there. Then even the laboratory doors. See, we in multinational industries, we used to go to such an extent that even the doors didn't have handles like this where you have to use your palm to open the door. Door should be openable just by pushing by your body. Because I know one incident. We used to work on one totally new insecticide. No material safety data sheet for that insecticide was available. It was highly irritative and corrosive chemical. And it was totally new chemical. We had developed it. And the person who was working on this insecticide had habit of going from one lab to another lab just for chit-chatting. And within a day, he went to at least 4 or 5 labs, and every door knob of each lab had a touch of that few milligrams of that chemical. And by evening, everyone working on that floor had an irritation or rash on their face or hands or palms, and it was a horrible situation. So always the door should be openable outside. If you are constructing a new lab, I am not recommending that you spend money on changing your doors. I did that in my entire building. I had done it. I changed the doors which were openable inside. I changed the door to opening outside. So in case of emergency, just with a push of a body, you should be able to run out and don't have to open it inside. Your hands, if suppose your hands are not free, if your hands are burned, how can you open a door which requires some kind of knob opening? So this is a must. If you are constructing a new laboratory, make sure these practices are followed. Another small precaution about distillation. I'm not going to spend much time on distillation, but you see at the collection flask, there is one small tube, which is an open to air tube. And there is a purpose for this tube, because the pressure should not be built up. This tube should be at least open to air, or nitrogen should be connected to keep an inert atmosphere, or a drying tube should be connected to it to keep it moisture free. But never close this tube with a cotton bud or something. I know one person working in a college laboratory had closed it because there was a ether smell, because he had not put proper cool water in the condenser. So ether smell was coming out. So to avoid the smell, he put some cotton bud inside this open side tube, and the entire flask developed a pressure, and it came out, and he was using a heating mantle, and he was using some sodium potassium alloy to make it absolutely dry. And it really like a bomb, the sodium potassium alloy came out with the burning ether and went all the way up to the top of the ceiling of the laboratory. The professor of that laboratory has still saved. Now, the professor died last year. I don't know about what happened this year, but till last year, I know the professor had saved this black spot on the ceiling just to remind his future students that never do this mistake. About feet and legs. Never wear chappals and sandals in the laboratory. I know a couple of incidences where somebody spilled sodium hydroxide solution. When you are heating sodium hydroxide in a big Erlenmeyer conical flask, say 10 liter, 20 liter, the conical flask or the Erlenmeyer flask, the bottom is not properly welded, or the glass blowing is not done properly, and it's a very weak joint. The sodium hydroxide eats away the joint, and if you lift the flask, because with sodium hydroxide dissolving in water or alcohol, heat is generated. Or if you are heating the flask, when you lift, invariably the bottom comes out and the entire sodium hydroxide falls on your legs and feet. And if you are not wearing normal closed leather shoes or canvas shoes or sports shoes, your legs are ruined like this. I have seen this accident in one of the university, and the student has these permanent marks. Never do this. Shoes are must. Sometimes ladies say, girls say, hey, how can I wear shoes like gents? No. We had a rule in our laboratory, in industry, as well as in our university, that even girls have to wear closed shoes, no excuses. Otherwise, they should not enter the laboratory. Even the visitors, we used to keep several extra pairs of shoes and goggles at the door. Visitors must wear closed shoes and no slippers, no sandals. You may be feeling, why is telling so much? Why is he going to such an extreme extent? Because I have seen many accidents all over the world. And if you have to make sure there is absolutely no accident, you have to take all these precautions. Sodium hydroxide I already told. Now I'm showing two beautiful girls. You may be wondering why in a safety lecture I'm showing this one girl wearing a sari and another girl having big long hair. There is a purpose. If you are working in a laboratory or any industry or wherever, always you should be wearing something which is not, like this sari where the pallu is floating on the floor, or like this girl who long hair which can get entangled anywhere. I know one accident which was caused. The one thing I already told about one girl in a college in 70s. Her hair burned because of sodium. She had hair like this only. Another girl I remember, she was working in a leather industry. Leather industry has machines for shaving the layer. You know, when they are processing the leather before they make your belts and shoes and purses, there are several steps. One of the steps is to shave the leather. The animal's hair are removed by shaving. And in that case, a big shaving machine is there. It is like a big press, and entire leather, which is like 6 feet long leather and 3 feet wide, it is inserted in the machine, and the knives are there, and they shave the leather. This girl had churida and a pallu of that, what you know as the Punjabi dress, Punjabi suit, and that pallu was hanging, and she was not even aware that the pallu also went along with the leather. Luckily, her colleague who saw that pallu also going inside, he immediately switched off the machine and saved her. Otherwise, after pallu, that girl's hand also would have forced, because there is a lot of force by that machine, where her hand also, fingers would have gone inside the machine. So remember, if you are having long pallu, long churida, the long Punjabi dress pallu or long hair, apron is a must, and all these things should be stuffed inside the apron. Nothing should be hanging outside. That is a must, absolutely must. Coming to cylinder safety, you are using nitrogen, hydrogen, air, oxygen, acetylene, so many cylinders of this shape. These cylinders, usually there is a practice I have seen, especially in colleges, many colleges in India, they don't tie it with a chain. They are just kept loose on a floor, and with any impact, they can fall down. I remember there was one institute where they had a luggage lift. Only luggage used to be sent in the lift up to 4th floor, not a human lift, luckily. And they sent one cylinder in that luggage lift. Luckily, it was an air cylinder, so not so dangerous. But with the jerk of the lift, they didn't have any cart like this. Any cylinder has to be always carried on a cart like this, tied with a chain. Or if it has to be standing against wall, it should be tied with a chain to a stand. So in this college, there was no such precaution, all pre-Bhopal days. Even today also people do the same thing. And the person sent the cylinder in the lift on the 4th floor. Unfortunately, the cylinder fell down. You know, when cylinder falls down, there is a great impact. And the weakest joint of the cylinder is the welded joint where the regulator is fixed to the cylinder. If that joint breaks, only God can save you. It was like a rocket. There was a hole at the end of the cylinder because the regulator came off, and through the hole, the compressed gas, which was in a liquid form, came out like a rocket, and the cylinder probably went here and there in the lift. The lift broke down, fell on the ground floor, and my God, it was such a lot of noise. And luckily, there was no human being inside the lift. Otherwise, he would have been smashed. So, always chaining a cylinder is a must, even if you are keeping it or even if you are carrying it anywhere. This is looks very funny accident. But one of my colleague in United States, he was from South America, very brilliant chap. Unfortunately, he died in a car accident a few years back, but very, very brilliant person. He worked on organo-aluminum compounds. You know, some of these organometallic compounds are always stored under kerosene or some solvent because otherwise they are pyrophoric. If they come in contact with air or moisture, they catch fire. So some of the very sensitive organo-aluminum compounds are also kept under solvent. So he used the organo-aluminum compound for his reaction, and then he was sitting on his table. You know, when we are sitting idle, we have a habit of putting our palm, putting our hand on our hair, on our forehead, on our face, on our ear. We just try to rub our face. Luckily, because of Corona, this habit has vanished. Many people now cannot put their hands on their face because now it is a practice last 1 year. Unless you wash your hands, you cannot touch your body parts. After Corona, many people have learned this. But this is again, I'm talking about 1984, 1985 accident. This person had a long beard. He completed his, addition of this organo-aluminum compound, very sensitive pyrophoric compound. And then he was sitting on a table and just he was touching his big beard. His hand had organo-aluminum. After few minutes, solvent evaporated, and whatever organo-aluminum compound was on his beard caught fire. His beard caught fire. This is not his photograph. These are taken from internet. But I remember the incidents. I was present at that time. Today we will laugh at these incidents if we see such a horrible picture. But my God, that was a horrible thing. Luckily, he was saved. Nothing much happened to him. He had too long beard, and that saved him. Now, storage of chemicals. Never store incompatible chemicals together. Never store HCl along with NaOH, acid along with base, reducing agents along with oxidizing agents. Never store, for example, the oxidizing agent potassium permanganate along with glycerine. They will catch fire if the bottles break. So always make sure there are two separate stores, or at least the racks are far away from each other. I had seen one chemist shop where he had kept potassium permanganate and glycerine on the shelf. I told him, he didn't understand what I was talking. He said, I'm selling this for last so many years. He didn't listen to me. And yes, one day, one of the bottle broke and he was about to have accident. Luckily, the other bottle didn't break, so the compounds didn't get mixed. But if both bottles would have broken, he would have had a severe accident, severe fire. Never keep unlabeled bottles. Every Friday evening, half an hour should be spent. If there are some totally unknown compounds in an unlabeled bottle, take help of your senior professor who is familiar with chemistry, or at least who is familiar with the history of the lab. Maybe he will remember, yes, this bottle, yes, I bought it 10 years back. It must be having sodium metal, something like that. So take help of your senior people and label the bottles. There are some corrosive chemicals where you cannot stick labels. The labels will come off. There, use plastic labels and hang them in the neck of the bottle. Such labels are available in the market. Those labels will not come off because there is no glue on those labels. Always have safety label on the bottle, whether it is oxidizing agent, explosive, or alkalizing agent, or extremely flammable, corrosive, whatever label is there, very toxic, should be there on each and every lab. Even your own samples must have this label, because whatever you have made may be having some unsafe effect. How to store solvents, flammable solvents? Flammable solvent should be stored in metal cupboard which has holes on the front and in the bottle. You can buy the cheapest possible Godrej or metal cupboard which is available in the market, or second-hand cupboard. Drill hole with a metal drilling machine, small holes, say 2 mm, 1 mm holes, and keep your solvents there. And if possible, keep the solvent away from your main laboratory. So in case there is accident, the main laboratory will be saved. And another restriction is never keep more than 30 liters of solvent in one laboratory. Because if there is more solvent, there may be a problem if there is a fire. So these are very essential precautions. Don't take it very lightly. If you are determined not to have a single accident, you must follow these precautions. These days, such cabinets are available. Tables with such under cabinets are available. Because, if the traditional cabinets, what we use, whatever is kept at the back, we don't have access. We can't even see the bottle. But today, the tables are available, which as soon as you open the door, the drawer also comes out automatically. There is a spring attached to it, and you can see each and every bottle even at the back. So such cabinets should be used. Your existing tables also, you can change the doors and the drawers to such things which are very useful, so that every day you can see what is inside the drawers. Also these days, some plastic coated drawers and tables and even the front is available, so nothing gets corroded. The tables look neat and clean, and that is the way the lab should look. Usually we are used to very dirty chemical laboratory, and that's why many new students, they hate chemistry. I remember once I went to South India. I go to many places all over India, even outside, to deliver lectures on many topics. And there I went to talk on career guidance. And I asked some girls there. They were in, I think, I don't remember, but they were not in chemistry, or I think they were in physics. Yeah. I asked them, why you like the physics? I mean, do you like physics? No, sir, we find physics difficult, but we don't like chemistry. I said, why? They said, chemistry is bad. Chemistry is smelling. Chemistry is dirty. And chemistry, you have to stand and do all the experiments. Physics is very peaceful. We have to sit on the stool and do the experiments. So we have to change the way people look at us. We chemists should make sure that people get attracted to chemistry. That is our responsibility. Now, quickly I'm going to show you few pictures. In this picture, this is a shelf which has, on the upper shelf, there are big bottles and heavy bottles. Lower shelf, there are small bottles and not much crowded. This is totally wrong way of keeping, because this shelf is standing against the wall. It is not fixed in the wall. Because of gravity, the upper shelf is heavy. It will topple down and there will be a major accident. So always heavy bottles should be at the bottom and lighter bottles should be at the top. This shelf is fixed in the wall, so that rule does not apply. So no harm in keeping the heavy bottles on top and lighter bottles on the bottom. But still this is wrong. Why? Because the bottles in the top shelf are above eye level. Safety rule is never keep anything above your eye level. You should be able to take out the bottle without any problem. If at all you have to take out the bottle from this top level, you have to climb a proper stool which is stable enough, and the bottle should be below your eye level. Then only you can take it out. The best thing, never have shelves which are above your eye level. Remember these safety precautions. These are very minor things, but they matter a lot when it comes to accident. Now this laboratory, this is the office of a person. And see, he has a sitting chair on the other extreme. But how untidy he is. He has kept even chemical bottles on the top shelf. He has kept everything. There is no table space left. Such office should not be there. You should not keep chemicals in your office, first thing. And if at all you keep, it should be very well kept, tidy, and no bottle should be on the top shelf above your eye level. So this is totally wrong way of keeping. This table is horrible. It is totally, mess. You can't even keep anything in case of emergency. Table should be neat and clean. This is another precaution when you are taking out solvents from drum. Many laboratories use bulk scale solvent because it is cheap to buy acetone in 100 liter, 50 liter drums. Whenever you are using a pump, even if it is a hand pump, even if it is a plastic pump, kerosene pump, use earthing. The drum should be earthed, because static electricity is produced moment you are using any kind of pump. Remember, any kind of pump will generate static electricity. It will generate a spark and there will be explosion. You remember in the petrol pumps, whenever the petrol is being unloaded, they do earthing and no other vehicle is allowed. Nobody should be talking on the mobile phone, etc., etc. Take utmost precautions because no accident should be there at any cost. Never use benzene, chloroform, chlorinated solvents. If you have to use them, make sure nothing falls on your hands because these are carcinogenic solvents. Make sure carbon tetrachloride, dichloromethane, etc. are used with utmost precaution. Even chemicals like acrylonitrile, they are sound very safe because nothing happens immediately. But I know a case where every day he used to use acrylonitrile for some making some IR cells using infrared spectroscopy. And these acrylonitrile, acetonitrile, these chemicals are known to cause damage to your kidneys if they are absorbed through your fingers or palm. So don't think that chemical didn't cause me any accident immediately. That means chemical is safe. For example, many students use dimethyl sulfate for methylation. That is a very good methylating agent, not only in your reaction, but even for your body. It can methylate the proteins in your hand and palm, and you will get cancer after many, many years. Cancer doesn't come immediately next day, or immediately doesn't come in the next hour, but at the end of your life, you will have cancer. There are many chemicals, you have to be very careful. I'm not trying to scare people. See, I have used almost all sorts of chemicals whole of my life with precautions. So precautions is a must. Respect these chemicals, like how to dilute concentrated sulfuric acid. You know, sulfuric acid, there is a way of diluting it. Never ever add water to sulfuric acid. Always take ice, very slowly, drop wise, add sulfuric acid to it and dilute it. Many students tell me, sir, I don't remember how to do this. Suppose by mistake, if I add water to sulfuric acid, what will happen? I tell them, remember how your mother makes pakoda or puri. She takes oils, she heats oil, and at that time, even if a drop of water falls in the oil makes sound and it pumps on your face. So remember that oil heated and added water is wrong. Same way, sulfuric acid and water added to it is wrong. Always take ice and add sulfuric acid very slowly. Respect phenol, respect acrylonitrile, respect cyanide, respect powder chemicals, because if they go in your lungs, you have a problem for your whole life. So wear the mask, take all safety precautions, then chemistry is very, very, very interesting and fun. I think those of you who are familiar with the innovations in chemistry, some really funny, some really interesting things you can do with chemistry. No other science can do that. About dangerous chemicals like cyanide, the precaution is the key of the cyanide cabinet should be, there should be two locks and the key should be kept with two separate persons. Like I used to keep many drums of cyanide and there used to be two locks. One key used to be with me and one key used to be with another responsible person. So in case, suppose by mistake, I open up the cyanide cabinet, I should not make a mistake of opening it alone. And I mean, there should not be any wrong motive behind opening the cyanide cabinet to cause some harm to somebody. So always cyanide should be under double lock so that nobody can play mischief with cyanides. Sulfuric acid, I already told you, the 5-liter bottle, the density is 2.8. So multiplied by 2.8. So it weighs almost 13-14 kilos. So don't hold it by neck. One hand should be under the bottle, and dilution I already told you. Concentrated nitric acid, if you are keeping it in a carboy, the plasticizer of the carboy is eaten away after a year or so. I remember in our pilot plant, one Sunday morning, one of my subordinate called me, sir, there is a lot of fume coming out in our pilot plant. I said, what happened? He said, we have kept many carboys, about 60 carboys of concentrated nitric acid, and one of the carboy is broken. I said, didn't we change the carboys? That is standard practice. He said, no, I forgot. Then I immediately rushed to our factory. We took a lot of precautions and poured the nitric acid in another vessel. So if you are storing it in a plastic container, nitric acid eats away the plasticizer, plastic gets brittle and breaks. So never store more than 1 year. So always label it to be, the container to be changed on before such and such date. That label should be there, painted on it, not a sticking label, because nitric acid is corrosive, the label will be eaten away. Chlorine, extremely dangerous cylinders, because the cylinders will get corroded. So before filling a cylinder with chlorine, get the cylinder tested, the wall should be tested, the chlorine should be tested for pressure, and never store it more than 6 months. There should be a painted label that the cylinder should be used or emptied before this date. I remember even small 1 liter cylinder. I had a 1 liter cylinder in the laboratory, and the date expiry date was over. So we immediately emptied the cylinder in water with proper precautions in a fume hood, so that the cylinder should not get corroded. That can cause accidents. I have seen chlorine accidents in industries, horrible accidents. Now I am through with my chemistry part. I am quickly coming to some other very important precautions. I know I am running out of time, another 18 minutes or so, or much before that, another 5 to 10 minutes I will be over. Mobile phones. I know 3 accidents caused by mobile phones. Unfortunately, or I don't know, coincidentally, all 3 were girls. One accident was caused on our staircase. We had this, on the left-hand side upper corner, you see a logo. On each and every step of our staircase, I had painted that don't use mobile phone while using the staircase. Still, one outside vendor girl had come to deliver something, and she used a mobile phone, and she was climbing down, and she slipped her foot and broke her leg. Never do that. Second, again, a lady outside vendor, because in our factory, everybody was given training. They will never even open the mobile phone inside the factory. But this outside lady, she finished her work and she was leaving the factory premises, and she was using those long heel, high heel shoes, and she walked out of the factory talking on the mobile phone. And on the both sides of the factory road, there were gutters with a jali on it, and her that long hill got stuck in that gutter jali. She sprained her leg. Third accident was horrible. One day, as soon as I entered my office, within few minutes, my secretary came literally crying, weeping. Immediately behind her, one policeman came, and he said, "Sir, do you know this lady?" And he had one full of blood identity card in his hand, and he showed me an identity card full of blood and asked me, "Sir, do you know this lady?" I said, "Yes, I know this lady in the identity card." He said, "This lady died today morning when she was crossing railway tracks talking on mobile phone." That girl was a trainee working with us. She did 2 mistakes: talking on mobile phone while crossing the tracks or walking on the road is totally unacceptable. Second thing, she was crossing the tracks without using the foot overbridge. Never make these mistakes. Life is not so cheap. Computers. Today, luckily, people use laptops and maybe small tablets, but many people still have these kind of computers, and people have a habit, because the table is too small, so they keep at the corner of the table, and many wires are connected: modem, mouse, keyboard, screen, whatnot. There are so many other earphone. Everything is connected, and the wires are jumbled, and if you try to stretch one wire, sometimes the computer falls. In one of the office, I remember one secretary broke her leg because of this. The computer was kept right at the corner of the table, and she tried to stretch one of the lab wire to make her keyboard free or mouse free, and the computer fell on her leg. She broke her leg. Never do that. Climbing up the ladder. First of all, if possible, use wooden ladder if you are doing electrical work. If not possible, the ladder should have rubber soles at the bottom. Third thing, make sure that the floor is totally dry. Here, see, this person has a wet floor and doing some electrical work. There are several rules about that. Rule number 1, we had a very strict rule in my company. If you are doing the electrical work, the person doing the electrical work, he himself should remove the porcelain fuses from the fuse box, keep in his own pocket. So even by mistake, nobody can switch on the main switch. So don't have circuit breakers the way they are today. Keep the traditional fuses. That is much safer. Take out the fuse, keep in your own pocket till you finish with your work. Second thing, check with a tester that by mistake the electricity is not on. In spite of removing fuses, sometimes there are so many fuses, you by mistake remove the different fuse and the current is still on. Never keep wet floor, never use a metal ladder, and never use a single ladder. I mean, this kind of sturdy ladder should be there. I know one person, a very senior engineer, a general manager in a company. He had purchased a new flat in Thane area, in outskirts of Mumbai. Just the day before Diwali, he wanted to hang a lantern, that kandil, the paper lantern in his balcony. He was staying on something like 15th floor or something on this multi-story building. The balcony was open. He climbed up like this and the electricity was not shut down. The holder had one live wire inside. Somehow he got a shock, and with that shock, he just fell down from the 13th floor to the ground, died on the spot day before Diwali. Can you imagine what would have happened to the family members the day before Diwali? Never make this mistake. There are periodic checks. I'll quickly go through this. Each and every check, like whether you have checked the first aid box, fire extinguisher, should be signed on the equipment itself. Balance, storage area, personal protective equipment condition, operation of personal protection equipment, a training given to people, cylinders, paint, everything has to be signed. Now I'm quickly going to show you some pictures, very interesting pictures, just pointing out when I have a physical lecture, today I'm talking on computer and there is not much time. So I'll just tell you answer also. I take quiz for students. So this is part of that quiz. Within a couple of minutes, I'll be finishing this quiz. See, in this case, the girl is standing next to a burner and her hair have caught fire. Then this person on the right hand side with the green t-shirt, his test tube is pointing to the face of this girl. So anytime the material come out, her face will also get burned. And that girl is not even wearing safety goggles. These are the wrong things. Here, the left hand side person named as Rick is smelling something from the beaker. This is not the way to smell. Your nose should be far away, or maybe with your hand, you should try to smell. The second girl is merrily pouring two liquids like a tap is open. Always pouring of liquids, addition of liquids should be very slowly, one at a time. The third person is pipetting or bubbling something in his solution like as if he is drinking Coca-Cola or Pepsi-Cola. Never do like this. Here, two boys are fighting with the scissors. Lab is not a fighting place. See a backpack and a football is lying on the ground. The red t-shirt person will stumble on that and they will fall down. The girl is eating her meals. See, she has her burger and Coke on the laboratory table. Never eat on the table. Here, this lady in the back, Penny, is putting lipstick inside the laboratory. Laboratory is not your living room or something. or mirror room where you can put lipstick. This Meredith is collecting the stuff in a proper manner with a broom, etc. But the other Jarvis, the boy, is collecting the broken glass with his hands, and he will have problems, he will have cuts on his hands. In this picture, at the back, the person A is just dancing with a football in his hand. That is, lab is not a place for dancing. Person B is not wearing goggles, and he is adding something, water to something. Wrong. The girl C at the back is not wearing goggles and doing something with test tubes without goggles. Person D is eating something with knife and fork on the table. Person E in the front, he is sitting on a stool as if he is sitting in front of a TV with one leg crossed on the other, and the test tube is directly pointing towards his face. Both gestures are totally wrong. Person F is eating a sandwich with right hand and pouring something, not even looking what he is pouring, or not even concentrating. He is talking to person E. The girl G has a Bunsen burner and a long hair. One hair is almost about to touch the burner. Then the person H is doing everything properly. She has apron, she has goggles, and the test tube is not pointing towards her. So accident reporting, I already told you. I will not spend much time. Now quickly I will show you some industrial accidents. Within a minute I will finish. This was one of the worst accident in 1924, caused because of ammonium sulfate and ammonium nitrate. These chemicals appear to be very simple and normal chemicals, but anything to do with nitrate, be careful. Anything to do with ammonium, be careful. These are used for gunpowders and bombs. Here, they are stacked in godowns, the gunny bags of ammonium sulfate and ammonium nitrate. Because of moisture, the gunny bags became soggy. The supervisor ordered that they should use the concrete drilling machine to separate the bags from each other. Moment the person used the drilling machine, because of the vibration jerk, ammonium nitrate ignited, and there was a big explosion. See the amount hole, all the sheds have fallen, entire factory collapsed, a huge factory collapsed, everything burned down. See the hole, it is as if you feel as if it's a well is formed. This is high pressure reactor. Many industries use high pressure reactor, many laboratories use small high pressure reactors, 1 liter, half a liter. They have to be tested periodically. The side of the reactors, the metal of the reactors has to be tested with ultrasonic by a proper company. All joints have to be tested, all walls have to be tested, rusting has to be tested, never use without testing. Propargyl chloride reaction. Propargyl chloride is used to manufacture vitamin A. Vitamin A is a very safe compound, but there were at least half a dozen accidents in last few years. Even during Corona, I remember there was an accident around Mumbai. Last year there was an accident. Year before last there was an accident. In fact, the blow was so much. Propargyl chloride can explode like anything. Even laboratory also. One has to be careful. Any new compound you are handling, take proper safety training. Without that, don't touch. Don't take a project. Even if you don't get money, it doesn't matter. Safety is first. Your life is first. Then explosion of butylene pipeline during cutting work. They didn't do proper precaution, which have to be taken. For any cutting, welding, a proper procedure is there. I will not go because I am not talking in front of industry people. When I talk in front of chemical engineering people, I go into details of these precautions. Basically, you have to make sure you take proper precautions. In Dhaka in 2012, a garment factory caught fire. Nobody knew the reason, but people could not escape because it is such a crowded instruments. Machinery was so crowded, people could not run away and died. Another in Bangladesh, 2013, 1 year after that, there was a complex where they had heavy machinery on the top floor, and the slab could not take the weight of that machinery, and slab collapsed. Many people died. So, in your laboratory, in your college, if you are buying some very heavy machine like NMR or whatever, make sure that your slab can take that weight. This is very important. In Kunshan, dust explosion in automobile paint factory. Even dust can explode if it is not treated properly. In Pakistan, the textile factory, the kerosene caught fire. And again, it was very congested area. Nobody could approach. They could not run away. And too many people working, they all died. Finally, this is my last slide. Quickly, I'll tell you one story because I have 2 minutes. Within half a minute, I'll finish the story. I was studying in a university in the United States. This incident happened in year 1980. This is the sort of secretariat, the state headquarters of that state where I was studying. And on 5th of February 1980, there was a major fire in this building. Early in the morning, 3 o'clock, nobody was in the building except the watchman at the ground floor. But due to winter, the temperatures used to be minus 30 in that town. And there used to be hot oil circulation entire building. So there was a central air conditioning which used to circulate hot oil on all the floors. And this oil got fire. And the fire went up to all the floors. All the floors caught fire. The fire brigade was just in the next building. Fire brigade came in less than a minute. The fire was extinguished. Everything was saved. But there was a big but. The oil which burned in the building, it burned without air because the building was totally closed because of winter. Every window was closed. Every door was closed. And it is known that certain oils, especially the chlorinated oils, if they burn without air, substances which are absolutely toxic, known as polychlorinated benzophenones, etc., that family of substances, they are formed in ppb level, parts per billion. In several lakhs of air, only one part of this chlorinated substance was formed. But it is dangerous. It causes damage to the next generations. So the people in that town took a firm decision. We will never ever open this building because it was impossible to clean the building. They knew that all the computers in the building are shut down permanently. All the state records, files, even the personal belongings of the employees, because they didn't know the previous day when they left that the building will be permanently sealed. So they had left something personal, maybe shoes or purse or something. Everything was permanently sealed. I'm very proud that people took this decision. That is the way people should take decision for safety. Safety is first, then comes important papers, then comes money, then comes cost of computers. Safety and human life is the first thing. Remember this message, and thank you very much for your patience. Thank you.
Thank you, sir. Thank you, sir, for your enthralling presentation. Whenever I get an opportunity to listen to you, I become transfixed with your lecture. Thank you, sir, for inspiring all of us. Please take care of your health and please accept my regards. Thank you,
Thank
sir.
you. Thank you. Thank you.
The forum is now open to the questions. Participants who wish to present their questions to the speakers may do so by typing them in the question section. Any question? Sir, there is one question from Priyanka. Sir, how and where the expired chemicals are disposed?
Okay. Her question is how the chemicals are disposed of, right?
Yes.
Okay.
Yes.
Yeah. Usually, every chemical, the disposal methods are available at two places. Number one, do Google search and search MSDS, that is Material Safety Data Sheet of that chemical. Every known chemical safety data sheets are available. And in the safety data sheet, everything about that chemical is available. The physical properties, chemical properties, how to dispose of, how to take care if it is spilled in the eyes, or if you are exposed, if it is spilled on the floor. Everything is written. So taking those precautions, you can dispose of that chemical. Certain standard practices are followed for different classes of chemicals. Maybe that standard instruction should be given to your people in your laboratories. Another thing is, there are certain catalogs of chemical manufacturers like or chemical suppliers like Aldrich catalog. They give everything about each and every chemical. There are some A to I different categories in which they tell the disposal methods. That is the quick method rather than searching MSDS. What practice we used to follow every morning, any reaction you are going to do, we used to have a 5-minute safety meeting with everybody in the department. We used to ask the person, do you know everything about the reaction? Are you comfortable? Do you have the MSDS of every chemical in this reaction? Even if he might be using that chemical for whole of his life, but the MSDS should be on his table. And because in case he is unconscious, somebody, the fireman should be able to open the MSDS and dispose of the chemical. So this is the practice one should follow.
Thank you, sir. Sir, one more question. Sir, can you please guide us on chemistry of outer space as a career?
Chemistry of?
Outer space.
Outer space?
Yes.
Yeah, as a, in terms of safety? Or it is a general question?
I think that it is a general question, sir.
Okay. Well, I have read a lot of things about chemistry of outer space. My professor himself was working on beginning of life. So he did a lot of experiments with gases and passing some spark through it, and how the chemicals were generated, etc. It's a topic by itself. Maybe some other time we'll talk on this topic at length. In such a short while, it will not be possible. But yes, it is very interesting subject. I love to talk on this. Like, I love to talk on new topics. Like yesterday, I had a talk on history and chemistry. These days, UGC encourages the combination of two departments. So I talked on war and chemistry, and it was very interesting for me also to prepare for that lecture. So like this outer space also, maybe some other time we will meet. Yeah. Okay.
Thank you, sir. Definitely, sir. Thank you. Thank you, sir, for all your time and for all your efforts. Please to take care of your health. Thank you, sir.
Thank you. Thank you. Yeah. Thanks for inviting me.
Thank you, sir. The second speaker of today is respected Dr. Gulshan Sheikh Madam. Madam was the Associate Professor retired and 8th Vice Principal Academics of St. Xavier's College, Mumbai. Imparting education has been a personal passion and the essence of her 38 years of service in one of the India's most reputed academic institutions. She has constantly adapted and expanded her skill set as a teacher with the ultimate aim of engaging students and successfully delivering challenges containing in an appealing and comprehensible fashion. An important aspect of this development has been her ability to conceptualize and employ different methods and strategies to create and sustain interest in learning. She prides herself in creating a questioning attitude among students and creating an environment which facilitates healthy interaction. However, her involvement as an academician and educator extends beyond the classroom and laboratory, in that she has constantly striven to pass on her knowledge in the form of teaching resources and pedagogically oriented mentoring. Further, Madam says that the responsibility of Vice Principal Academics has not only helped her to develop her administrative and organizational and executive capabilities, but also understand the students. Post-retirement, Madam has been actively involved in the Homi Bhabha Center for Science Education, Mankut, Mumbai. Her involvement in this institution has enhanced her awareness of the importance of educational pedagogies and the need for continuous growth, leaving her with the feeling always that students have an immense potential and it is up to us teachers to own this wealth to greater heights. May I now welcome our respected madam to deliver the session. Madam, please.
Thank you, Amrit.
Thank
Am I
you.
audible enough?
Yes, ma'am. Yes. Ma'am.
Yes. So, okay. Let me start sharing the screen. Yeah. So,
Yes.
is the screen visible to all?
Yes. Yes.
Yeah.
It is visible.
All right. So, I really, I'm grateful I heard this particular session along with the others, which has given me a totally new perspective of so many different things that people have spoken about. Particularly, Dr. Chobe just now has given us, in a very beautiful, simple way, how to be safe in the lab. And somewhere along my presentation, I would be definitely asking you all to recall all that has happened. And so let me begin in a very formal way. We are in the final day of the chemistry orientation for UG and PG students, which has been made possible by the ACT, Association of Chemistry Teachers, in collaboration with the Government General Degree College, Singur, and the Rani Rashmoni Green University, Tarakeshwar. Thank you all, organizers and collaborators, for making this happen. And of course, this has happened because of a very enthusiastic and determined Dr. Amrit Mishra, who's the convener of this conference. Thank you, Amrit. I have begun to know you personally of late, yes, but I really admire the way you have brought so many people, half a dozen resource people from different backgrounds, the only common factor being chemistry, together on this platform, and targeting it for a student population without any demarcation between the UG and the PG students. I'm really honored to be here today. And I have chosen one small domain of organic chemistry practicals, which is the organic spotting. You might be familiar with organic spotting, maybe calling it different names in your different institutes. But the basic principle behind this term is are you able to see the lettering on the slide, Amrit?
Yes, ma'am. Yes, ma'am.
Or are you able to see it as a slideshow, or are you able to see it as a regular slide?
Regular slides, ma'am. It's not in the slideshow.
Okay. So it's a similar problem that Dr. Chobe had. Yeah. So let me just try once again.
Okay.
Yeah. So are you seeing a white screen right now?
No, ma'am.
No, not at all. Okay. All right. So may I just go to the Google and see if that will be possible, Amrit?
Yes, ma'am.
As Google Slides? Yeah. Just give me
Yes, ma'am. Yes. So that will be better, ma'am.
Yeah.
Open it via Google Slide.
Right. Oh, yes. Proceed. It's not a Google Slide. Okay. Right, just a minute. Because again, I really don't know what the problem is. When I was trying to do it, it
Yes,
was pretty much okay, but the whole charm will go if I'm not able to get it on Google. Let's see. Yeah, I've just gone on to Google Drive. Yeah,
okay, ma'am.
and it's loading.
Yes, ma'am. Actually, the whole Google Drive is now visible.
Okay, fine. So let me just do that. Yeah, you'll have to guide me from there what I'm able to see. Can you see now? The
No,
screen
ma'am.
is becoming
No, ma'am.
visible.
No, ma'am. It went
It
off.
hasn't loaded yet. It takes time.
Yes, ma'am. There is a yes, ma'am. Yes, ma'am. It's perfect now.
Okay.
Yes,
It's perfect.
yes, ma'am.
Voice is also audible.
Yes, ma'am. Yes, ma'am.
Okay.
Loud and clear.
Yeah, fine. So, yeah, thank you so much for the guidance and the patience. So, let's see. As I was telling you all, I picked up a small domain of organic chemistry practical, which is the organic spotting, which is basically about identification of organic compounds. But I've given it a very different title, which is spot the spotting. So when I'm talking about the title, I'm basically want you all to think about organic spotting as your experiment domain. Within that, the identification of organic compounds. And this is my my little name and about a little bit about me. And this is my email ID, so you can note it down. You can note it down, and when the minute I say note it down, you're going to have a lot of noting down to do all along, because I'm going to start with a small introduction, which is very, very simple. And since it is going to be about organic spotting, I'm assuming that most of you are familiar with organic spotting and have done it. So if you're familiar with it, I would still like you to be patient and just listen to what we have to say. Because when your turn comes to participate and give a response, I will tell you how. I mean, definitely you're going to be a little more, happy that you got something. It is something that you're already familiar with. That feeling is always there. So even if it is basic, please have an open mind about what you're going to be hearing for the next whatever time I'm going to take. I hope to keep to the time that has been allotted to me. I want you all to understand identification of organic compounds as a fascinating journey. And the main focus is obviously to identify the functional group or groups that is or are present in an organic molecule. That is the main focus, functional group FG, as is popularly called. And for this, a number of physical and chemical tests are used in a very logical sequence. And we hope that this logical sequence is followed by all who are dabbling into these kind of experiments. Ultimately, after doing the sequence, we confirm a compound by using physical properties and a little more. Physical property most commonly used in a lab, UG or PG, is the melting point or the boiling point, depending on the state of the compound. And we do have a very specific chemical test to confirm the compound. So that is how I would like you to recall an organic spotting at this particular moment. Again, the gap from the lab is kind of, indirectly helping me to bring you into the focus of an experimentation thinking process. What are the instructions that I want you all to keep in mind whilst this presentation is going on? I want all of you to look at organic compounds from structural features. And when I say structural features, I mean look at the skeleton of the compound. Is it open? Is it closed? Is it saturated? Is it unsaturated? Is it aromatic? Okay. How many elements are there? What are the elements and things like that? I want you all to limit yourself to compounds containing only one functional group. So monofunctional group. So I understand the compound structure and I'm looking at either an alcohol or an ester or a carboxylic acid and things like that. I'm not having more than one functional group in my system. So keeping it to very simple collection of organic compounds. I also want you to relate or collate a number of observations that I'm going to keep throwing at you to assist in the identification. So I'm not elaborating more on what the observations are at the moment. I'll expect you to be with me all along. And the major instruction is the tasks before you. It's plural, so it's more than one, is in a participative format where you're required to think and come up with responses. Okay? So you are going to be thinking along with me, and I'll ask you for responses, maybe in a very different way from the usual, can you tell me this? Not so directly, but there will be some kind of a response from your side. So I would expect you to keep a paper and a pen ready from this moment. Okay? So a paper and a pen or a pencil, whatever you want to write with, not the laptop, you'll need to be jotting down. All right? And if possible, I shall give you a little bit of a push or a direction into what and how to write whatever I want you to write. Is the instruction clear? All right? Just before that, Amrit, do you have, can you get the chat show reading if possible? Are you able to do that? I want the participants to respond in just one word, what they feel about organic spotting that they've already been doing in the lab. That one word could be your first feeling that you have, whether you're scared or comfortable or uneasy or excited. Those kind of words I want to come. Even if I have a handful of them, I get an impression as to what you're feeling about organic spotting. So Amrit, I'm not able to see the chat. Are you able to see and tell me the chat, please? The responses? Amrit, are you with me?
Yes, ma'am. Yes.
Okay. So are you able to see the responses as to what they feel about organic spotting? Even if one or two are there, I have no issues. You can just read them out to me. Yeah.
Yes, ma'am. One is saying that it is quite exciting.
Okay, that's nice. That's nice. Thank you, Vaishnavi. It is exciting, yes. And anything else that's come up?
Amazing, incredible, carefully done, charming, enthusiastic.
Okay. So a lot of positive responses have come in, which I'm really, really happy about. Anything which is not so positive, less positive. Anybody feel scared?
No, ma'am, not yet.
Okay, not yet. Mesmerizing. Oh, wow. This is really, really good. Okay, so enough to start with now. So I do recollect some of these words immediately, and I hope to remember them by the time I would come back to it much later. Okay, so I hope by now you've got your paper and pen ready. Let's move on. This is a fresh start. You have an open mind. And I'm telling you that a preliminary investigation of state, color, odor can be used to identify the class an organic compound belongs to, a statement which I'm making. At the same time, I want you to recall what Dr. Chobe just said a while ago about smelling compounds, right? So we cannot, and we would like to avoid smelling compounds directly because there is a risk in that. The state, yes, solid, liquid. I'm not talking about gaseous compounds at all. I don't consider them right now. I'm talking about either a solid state or a liquid state compound. Color is visible, very, very clear. So this is my first investigation, okay? And I'm taking examples to highlight one or two of those investigation features. A brown color is likely to indicate presence of an amino functional group. It could be a phenolic functional group as well, and there are others, but at least I can understand that if there's a brown coloration to a compound, it may be an amino functional group. That's my inference. Similarly, if there's a very pleasant smell, which, even when the sample before me is far away, I can smell. Like when somebody has sprayed a perfume, I can smell it. I can definitely recognize the smell. And then I can say that there is the probability of an ester functional group which causes a pleasant smell in the compound. Two very, very simple, relatable observations with these examples. Okay. At the first of my responses that you want begins now. All right? Wait for me to tell you when and how. I'm talking about color of organic compounds, and thanks to Wikipedia, I've got 4 images of organic compounds in the pure state, which are here. Okay? 1, 2, 3, and 4. So I have these 4 compounds, and the colors are obviously white, red, again white, and yellow. I assume that all of you are familiar and can understand that these are the colors that are matching the compounds, the images that I showed. Let's go ahead. I'm looking at the same concept of color, and I want to relate it to structure of compounds. Okay? So I have a table before you which is related to the earlier set of 4 compounds. I've got those 4 compounds with the names as of now, and the colors that I could see in the earlier slide are white, red, and yellow. And the compounds are 2,4-dinitrobenzene, chlorobenzene, benzoic acid, 2,4-dinitrophenhydrazine, and oxalic acid. The structures are here. So there's no dispute about it. I have a name and I have a structure. You have the colors seen, observed color. Can you fill up the last row and identify what could be the probable color of 2,4-dinitrochlorobenzene, what could be that of benzoic acid, and the other 2? Put it down in your sheet. I'm giving you about 20 seconds to do that because I want quick responses. And I'd like to share the answers with you. This is an exercise which I want you to participate. So to make it more fun, I want each one of you who's responding with answers on your sheets to compare your answers with mine as I put them and give yourself points. So for every response that matches your paper and what I'm showing, give yourself 1 point. So you are kind of self-evaluating yourself as we are progressing. I hope this instruction is clear. Let me fill this up with the answers, and maybe you can understand what I meant by write your own scores. What you wrote should match with my answers. Yellow, white, red, and white in that sequence. Each answer is value of 1 point. So if in your participation, if in your responses, you've got all the 4 answers, give yourself a score of 4. I hope some of you are playing this game as we proceed. So 4 points for slide number 6. If each one is right, 4 and 4. Otherwise, mark yourself. Doesn't matter if it's 0 and 4 also. It's just for fun and it's for you and yourself only. Next slide. I want some reflection on color done. The colors that we've seen with the structures that are evident. What could the relationship be? Is there any relationship between color and structure of an organic compound? Now, you heard yesterday, particularly, colors that were recognized in the octahedral complex that Dr. Anupa said, and of course, the various wavelengths of different colors. I'm not going into more, but the minute you recall that, and I have this question posed before you with respect to organic compounds. Is there any relationship between color and structure of an organic compound? The answer is either yes or it's no. So again, if you've answered any one, which is the right answer, you will give yourself 1 point. You've thought of the answer by now, I'm sure. The answer is yes. So 1 point for all those who've answered that particular question. What could it be? What is the relationship? Bring back certain ideas about organic compounds, particularly the structures. What is it in the structure? I mentioned a few areas earlier. If you can recall them quickly, then you'll be able to identify it. Write down whatever you think. Words only will do, because I'm not going to see your answers. You're going to mark it yourself. So I'll give you about, again, 10 seconds to do that. And here we have now the responses. Some of them at least are, it is the bonds probably, which could be sigma or pi. It could be the electrons, because bonds are because of electrons. There are more than the bonded pair. You have the lone pair also. You have a functional group, which is responsible. I'm sure you're able to recall more and more theoretical chemistry by this. And you have a pattern. I love the way Dr. Sumana Datta spoke about patterns in systems. Now I'm trying to make you pull out that just one word of a pattern and apply it to the earlier 3 answers. Is there a pattern of the bonds in the structure? Is there a pattern of the electrons in the structure? Is the functional group on the system that you're considering in a particular pattern? Think about it. I've said reflection. I'm not going to go into the descriptive answers. At the same time, I also want you to recall some other words that you have heard and understood probably. Words like oxochromes, chromophore, hypsochromic, bathochromic. Just consider this entire set of words and terms that I've used to understand completely the relationship between color and structure of organic compounds. So from slide 7, you would get 5 points, 1 for yes. And if you've got even, each of those or something totally new, doesn't matter. If you think it's going to fit into this answer and statements that I've made, go ahead, give yourself your marks. The second aspect is a Beilstein's test. And a little information, a little differently understood. Let me go into that. Organic compounds are dominated by carbon-hydrogen proportion. That's how organic compounds are defined. They are compounds of carbon and hydrogen with other elements is the most repetitive definition given in books. And this proportion can be qualitatively identified by a simple test known as a Beilstein's test, which is burning a small amount of an organic compound on a copper foil in an oxidizing flame. Okay. This is a website and a YouTube video, which is about 3 minutes run. Amrit, may I have your permission to show this?
Yes, ma'am, definitely.
And I hope I can get back to this also. Yeah, it's kind of open, so I'm lucky. Okay, so it's opening. I want you to watch the video carefully, and I hope the sound comes along with it. If not, doesn't matter, just see the visual. Okay, so I have it. It's on full screen, and let it load. Are you able to listen or hear the audio? Okay. If the audio is not clear, no problem. Just watch the visual. Okay, let it continue loading. So far what has happened is they are the speaker is talking about how to use the Beilstein's test using a copper wire, holding it in the flame of a Bunsen burner, how to use and what precautions to take, that there should be no HCl and other systems close by, and we have it happening. Okay, it's taking its own time to load. If it doesn't happen in the next 1 minute or so, then I shall move on to that, move beyond that. This is important to get the copper wire cleaned completely. Watch the flame. Okay, so try and catch the words. Watch carefully, please. See what's happening to the flame. Yeah, it's so very interesting, the colors, how they can be developed. Wow. Okay. All right. So coming back to where we were. Okay, now I have to just go down a little bit. Are you able to see my slideshow? Okay. Yeah. So I'll just stop presenting and I'll join back because I don't know how else to do that. Okay. Wait. Just a minute, Amrit.
Problem, ma'am.
Yeah. Yeah. So, yes. So we were at this, right?
Yes.
So now the last line, I hope it's visible. We therefore can use a Beilstein's test to even detect halogen. So we've got different flames in that video. I'm not going to explain anything right now or make you relate anything. I hope the visual has made its own impact with the examples that the gentleman chose in his presentation, in his video presentation. Another aspect, I want you to consider the general elemental representation of an organic compound. I have a unique formula here, and I want you to understand P, Q, R, and S subscripts are real numbers, and X is a heteroact element, which is maybe nitrogen, sulfur, chlorine, bromine, iodine, or whatever it is, okay? And I want you to complete the following table. I have 4 compounds in my name list, and I want you to write down the elemental representations of those 4 compounds in the format that has been identified. How much of C, how much of H, how much of 0, and how much of X. And whilst you're filling up your paper and your table, keep it as a table which is going to grow row by row below the representation. I hope you've got that clear. Keep it in the same format, and you're going to keep adding rows to it when we move to the next slide. The elemental representation that I've shown here is very significant, especially for those who are searching for compounds in search engines. You will often come across CHO something, and therefore you have to become familiar with identifying compounds, organic compounds in this representation. By this, I hope that some of you have got the answers, and I'm showing the answers here. Benzene is C6H6, but in line with what we have asked you to do, it is O0X0. Ethanol is C2H6O1X0. Bromobenzene is C6H5O0Br. So here X is replaced by Br. And methyl acetate is C3H6O2X0. So 4 points if you've got all 4 right. If you've not written down O0 and for X, deduct half a mark. That's all I would say. I will not say more than that. Rather than lose out on something, you've attempted it. So I would still like you to get some advantage of the score. Okay? So 4 points for slide 9. As I told you earlier, I'm going to continue this table format, build it row by row. You've got those 4 answers already. Now fill up the row after that, which is a CH proportion. You've got the answer above you. Pull out from there only for C and H the proportion of the 2 elements. Take about 10 seconds. It's not so difficult. It's already there. You just have to rewrite it, but in a shorter way. So, for benzene, it is C6H6. For ethanol, it is C2H6. For bromobenzene, it's C6H5. For methyl acetate, it is C3H6. This, I don't think anybody can go wrong if the first four are correctly written. 4 points for this as well. The third row, start thinking along with me. Which of those above 4 CH proportion has the highest carbon content in proportion to hydrogen? Highest carbon content. And similarly, the other end of that particular scale, which has the lowest carbon content. The answer, highest is C6H6 because it's a 1-to-1 relationship. Okay? Now, if you've got this understood 1-to-1 relationship, even if you had not marked that, I'm sure you'll be able to mark the lowest carbon content. The lowest carbon content, my response is C2H6. For every 1 carbon atom, there are 3 hydrogen atoms. It's only 1-1 answer because when I say highest and when I say lowest, obviously I only want 1-1 answer. Okay? Moving on is the Beilstein's test result. And in the Beilstein's test result, you have seen the video, and I'm quickly recalling some features of the video. You had a flame which was either yellow or non-yellow, and you had a flame which was green entirely. The green obviously was, as the title of the video, because of the halogen present. So in this second last row, what I wanted to fill up is, what do you think is the answer to the color of the flame if you had taken benzene, then ethanol, then bromobenzene, and methyl acetate? Okay? A yellow flame in our organic chemistry terminology is generally called a sooty flame. And a non-yellow, which means the flame of the burner itself, assuming it's an oxidizing flame, it will be bluish, will be non-sooty. And a green is very distinct. Okay? So the answers, as you have written down, I'm writing down. Beilstein's test with benzene gives you a sooty flame. So my symbol will be S. Ethanol is a non-sooty flame, right? Because it has the lowest carbon content. Now with these two answers, link it up to the highest and the lowest, and I'm making a statement, see if that makes sense. If the carbon content is high, it will burn off with soot. Therefore, sooty flame. If the carbon content is low, there is no excess carbon, therefore you will have a non-sooty flame. The third one, bromobenzene, green obviously, but there is a high percentage of or high carbon content, therefore it will still be sooty. So S and G for green combined. The methyl acetate is having a low carbon content and it will give us a non-sooty flame. The last row, 4 marks again, if you've got this, maybe in your own way, but at least if you've got these indications, and henceforth, this will be the terminology used for Beilstein's test. The last row is nature. When I say nature, I want you to think of a structural nature, if I could use that phrase. All right? How are the carbon-hydrogen bonds in benzene? or in ethanol, or in bromobenzene, or in methyl acetate. That's what I want you to pull out when I say the nature. Doesn't matter if you've not got it, I'll give you a lead. I will say the nature, because of the bonding for benzene, is aromatic. Everybody knows it. That's the introduction to aromatic compounds. I also wanted to link it up with, it is aromatic, hence it has a high carbon content and will give a sooty flame for Beilstein's test. Can you link up the column as well? That's how I want you to start thinking. Now, as compared to aromatic, what can I use for ethanol? This will already give you a tip as to what the nature could be. If it is as aliphatic, give yourself 1 point. Ethanol is an aliphatic system, therefore obviously the carbon content is lower than an aromatic system, and it will give me a non-sooty flame. Similarly, the nature of bromobenzene, it is aromatic and halogen containing. And finally for methyl acetate, it is aliphatic. So these words that are a little more highlighted because of the filled up areas, 3 of them as of now, aromatic, aliphatic, aromatic, and X. I would probably expect another combination, aliphatic and X. Are the nature of organic compounds based on their observations of Beilstein's test? The observations of Beilstein's test can be derived looking at the structure. So slide 10 should give you a maximum of 14 points. 4 4s are 16, 4 4s are 16 plus 2, that's 18. I've already taken those 4 points in the earlier case. Okay? Right. So we are using all this information now to do another table, match. I have just 3 structures: benzoic acid, chloroform, ethyl acetate. I want you all to predict the flame. We are on slide 11, and the predicted flame, as I earlier said with respect to the earlier slide, depends on the carbon-hydrogen content, carbon-hydrogen bonds that are there in the system. Not wasting time, not waiting for a longer period. This has to give a sooty flame. Benzene gave, so benzoic acid is a derivative of benzene, so I expect some path to continue. Chloroform, it's got halogen, but there's no unsaturation, leave alone the aromatic nucleus, therefore it will give me a non-sooty and a green flame. Ethyl acetate will give me a non-sooty flame, hence, these are my natures. As I said, aliphatic and X combination, here is an example of that. So slide 11, again score yourself if your answers match. The next area is solubility in water, alkaline and acidic solutions. You've done it so many times, and it helps you in categorizing compounds according to their chemical nature. The asterisk has a relevance, which you'll see as I move on. Here, there's the sequence of testing to be followed. Again, try and recall, though you've been away from the lab for so long, try and recall the ones who have done these experiments earlier. What is the sequence? Is it the way that it is shown? Solubility in water, followed by saturated bicarbonate, followed by dilute sodium hydroxide, followed by dilute HCl. The sequence is rigid. Take my words and take them seriously. The sequence is rigid. The last cannot be done first, neither can the order be broken. It has to be taken in a certain order. Some more information a little later. And all the tests have to be performed in the cold, and shaking the test tube in which the tests are done shaking the test tube is necessary. Cold is another condition to be maintained, and shaking the test tube content is another condition. So we are selecting one at a time from a sequence. We are using cold solutions and we are using agitation to mix the compound with the solution and observe what is happening. What can my observation be? We are testing for solubility. So the obvious observation is the compound that I have taken for testing soluble or not? So what can it be? It is giving me a glance or a glimpse of the chemical nature. What can they be? They can be water soluble. They can be acidic if they are dissolving completely in saturated bicarbonate. They can be phenolic if they've dissolved in dilute sodium hydroxide. They can be basic if they have dissolved in dilute HCl. The sequence rigidity is very, very important. I'm not saying anything more. I'm sure you're able to think and figure out why. Question yourself. Remember what Neeraja ma'am said, questioning is powerful. Question yourself. And we have a lot of flexibility at this point. If they can't be those four, then my assumption is that the compound that I have in my hand to work with is neutral. So basically, inverted commas, chemical nature can be a water-soluble system, an acidic system, a phenolic system, a basic system. If none of those are seen, then neutral. Assuming again, they are monofunctional groups. And with all those other conditions fulfilled. Okay? No mark for this slide. So now I'm throwing you an instruction. Predict the solubility of the compound by examining the structure and the probable chemical nature. All right. So we have this. 4-nitrotoluene, naphthol, cinnamic acid, urea, and 4-aminotoluene are the compounds. Solubility in water, bicarbonate, dilute NaOH, HCl. I put them down in a vertical sequence, but the instruction is the same, one after the other. So I take one test tube. I take in an empty test tube, few drops of 4-nitrotoluene. I run through that. Similarly, with the next one, with the next one, with the next one. Visualize. But instead of doing an experiment, I'm looking at the structure now, 4-nitrotoluene, etc., 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 and I'm going to predict. I'm starting the answers. 4-aminotoluene is soluble in dilute HCl. I've shown you that indication. Yes or no? It's an amino system. Amino systems should dissolve in dilute HCl. And therefore, what is my answer? My answer is a 4-aminotoluene is basic. The exercise has started. If you have got before me the responses, give yourselves 2 marks, one for the arrow and one for the word basic. Similarly, 2-naphthol, I've recognized that there's a phenolic group which will be soluble in dilute NaOH. I've already gave you the chemical nature. It is phenolic. I know something else which is staring at me because of the name. Urea, soluble in water. I expect you to know this because urea as an organic compound has got a lot of historical significance. Thanks to Neeraja ma'am, she said there's a history of compounds. It's the first organic compound that has been synthesized outside the living system, and therefore Wohler's first synthesis, etc., etc. It's very interesting. I want you to read it. Also, urea is popularly used as a plant fertilizer. I use it for my plants. Everybody uses it. It's a water-soluble fertilizer. So I know. You know that urea is water soluble. Okay? It's neutral. If I remember the structure of urea, it is a neutral system. All right? Keep this in mind because we are going to come to it a little later, maybe much little later or something like that. So what are we left with? We are left with cinnamic acid, which is an acid. It has to dissolve in bicarbonate, and therefore the nature is acidic. We're left with 4-nitrotoluene. I know there's a nitro group, there's a CH3 group, that much I know. I understand the name, and therefore I know a structure. Nitro group is therefore neutral. There's no chemical test to understand how to detect a nitro group on the basis of solubility. It's going to be insoluble in every 4 of those solutions or solvents, whatever way you want to see it. So slide number 13 has given you 10 marks, should give you 10 marks. Okay, there was one thing which I wanted to show you. Let me go back to that. There is this. Cinnamic acid will also dissolve in dilute NaOH. There is no doubt about it. I'm giving you the explanation now. Even if you know it, just kind of bring it back in your minds. An acid, like cinnamic acid, definitely is acidic, and all acids will dissolve in alkali, therefore it has dissolved in sodium hydroxide. I've given you the explanation for this, and I want you to also think about something else, particularly with respect to the water-soluble system, that is urea, which I will come back to later. Elemental detection. We understood the Beilstein's test, which was exclusively a qualitative test, though it might sound a little difficult to do. We are talking about the Lassane's test for hetero elements more than halogen, and remembering Professor Chaube's talk, it's fusion of the compound with metallic sodium by strong heating. He spent a lot of time in talking about metallic sodium, the risks, the hazard. So this particular test, done in an organic spotting, has to be done with all those precautions kept in mind, especially the don'ts and the do's of handling metallic sodium. Okay, but for our purpose, this is how the test goes. It's fused with metallic sodium. Then it is extracted, the residue is extracted by boiling with water, and we are using small portions of this extract to test the more commonly found heteroatoms, which are NSCl, Br, and I. These heteroatoms are converted to the halides, which are these. Okay? Equations involved are, I'm just rushing through this because they are inorganic reactions and organic reactions. I would say more, they are more inorganic, and no chemistry is without equations, so it has its due position here. These are all equations which you should be familiar with. You should know it almost on your fingertips so you can understand what you're doing and what is happening when you're doing the Lassane's test. Again, if it's as a sulfide, you have this complex, and this complex is a violet color. You've used nitroprusside iron for checking with the extract. And there's another method to check for sulfide ions. Lead acetate and sulfide gives you lead acetate precipitate. Chloride checking qualitatively is so easy. God knows since how many years you've been understanding that. And this is what we use also from the Lassane's test. Okay, fine. Now, for us, for our purpose, I'm going to put the whole summary of elemental detection together. We did the fusion with sodium first. We're converting elemental NS and X to anions, CN, S, SCN, and X. SCN, the thiocyanate, is when you have sulfur, nitrogen combined in an organic compound. All right? We are detecting the generated ions qualitatively, simple tests, more inorganic in that, if not entirely. Then we're deriving an inference from there that if we have got the halide ion present, and from our qualitative test, we know that the original compound had halogen, which was also supported by the Beilstein's test. Okay, so we now the compound has, in addition to X, which was earlier detected, we can also reconfirm it, and we can also detect nitrogen and sulfur by using these tests. Okay, so it's an important aspect of an organic compound detection, elemental detection. Functional group. Again, by simple chemical tests, monofunctional groups, because each of them will have a specific test. Again, with due respect to Professor Chobe, once again, I'm pulling up metallic sodium. And this particular test, it's such a beautiful coincidence. He explained it. And I want you to remember what he has explained. And therefore, the answer to this is so simple. What is the functional group that is detected by this reagent? Undoubtedly, it's a hydroxy-functional group, OH, because I remember he's mentioned higher alcohols, which are to dissolve that block of sodium metal that is left behind and things like that. Okay, so I've just picked up one specific chemical test. I didn't know that Professor Chobe would be talking on it, but I'm glad. So it kind of backs up my instruction about be careful how you handle your chemicals in an organic chemistry lab. Okay. For organic spotting, the regular method is individually identifying the compound with a logical sequence, set of observations, confirmation. Now what we do is we consider a set of organic compounds and using the information we just went through and some additional assistance, try to spot the spotting. So again, once more, I want you to have my instruction, which is very, very clear. Okay, this is my instruction. Be ready with the paper and pen. Never mind if you didn't have it earlier, jolly well have it now. Write down the relevant information as I proceed and then check with whatever responses are being shown. I'll follow the same pattern of showing the responses so you can check them. You can evaluate your own work. Amrit, how much time do I have, Amrit?
Madam, around 15 more minutes.
Okay, fine. All right. So let's move on with this. I want you to examine the structures which are here now. As I'm showing them, quickly write down the name in the order that has been written down, preferably. Otherwise, no issues. We can use them juggled also. So you have these 10 organic compounds. The structures are there. They are simple structures. Not one of them will be difficult to recognize and give it a name. All right? So you've done that already. Now, fill the columns with the most appropriate option or options provided for the two tests, which means I'm implying to you that there is a table coming up and there are two tests which are there. I'm naming them also because I'm using Beilstein's test and I want you to fill the columns as non-sooty, sooty, green, which are already done in a very short exercise. So there's no harm, there is no difficulty. And I also want you to fill up the solubility columns, okay? Whether it's soluble or insoluble. Doesn't matter if you ignore the insoluble filling up because that may take time. As long as you're identifying the soluble thing is more relevant. And just the hint that I've already given here, whatever we infer in a definite way, we label it a positive result. The positive result means we've got something encouraging and therefore we can use that for the subsequent checking. That's how I would like you to see it. Insoluble is not as positive as a soluble. Of course, you can use that inference as well, but we even proceed further. Okay? So here we are going to fill up the table. 10 names in the order of the numbers. If you've got those 10 names, mark yourself 1 point per name. Just mark. So you have 10 points already. You've got the structures before you. I hope you have jotted it down. So looking at the structures, fill up S, NS, and SX, NSX as they may be. Okay? So the answers are here. These are all the sooty compounds, some sooty flames. Therefore, they are all the aromatics. Just quickly compare. Those who have not filled up also can now catch up. The rest of them, urea is non-sooty and ethyl acetate is non-sooty. They are both aliphatic. Chlorobenzene. You saw the video for bromobenzene. How different can it be? So it's sooty and green. You saw the structure in the table and you filled up earlier for chloroform. It is non-sooty and green. Okay, so some past and some new. Solubility. I've given you this answer. You only derived it. Urea is water soluble. All right. So if you look at the names, you can immediately recognize an acid, a naphthol, a benzamide, an aminotoluene. So very rapidly, let's fill up. There's only one acid, benzoic acid. Okay? There's only one naphthol, which is soluble in sodium hydroxide. There's no other phenolic functional group present. There's only one amino group compound, therefore that is soluble in dilute HCl. All right? Now, if you've got these 4 of the solubility, 4 marks. And since I already gave you a hint, 1 mark for this, for benzoic acid, which will be soluble in both bicarbonate and dilute sodium hydroxide. At this point, the relevance of the sequence, if I just picked up benzoic acid and I added sodium hydroxide to it accidentally or defiantly, because I'm not going to go according to the order, I will find that the compound has dissolved. Therefore, my inference will be that the compound given to me is acidic, is not really acidic in that sense, but it is phenolic. So I've entered a wrong domain of compounds. But if I'd done the bicarbonate test before that, I would have understood that there was effervescence, it is soluble, so it is acidic. So ideally speaking, as I mentioned in some different contexts, the minute you get a positive indication in a sequence, you stop. Because a compound cannot be more than one chemical nature. If it's soluble in sodium bicarbonate saturate solution, there is no need to go beyond that. If it's soluble in dilute sodium hydroxide, insoluble in bicarbonate, insoluble in water, yes, that is the direction. But I had asked you all to think about water-soluble urea, and now I'm asking you if in the same row as urea, whether that compound urea will be soluble in water, yes. But if you had skipped that by accident and you try sodium bicarbonate, would the compound dissolve? Interestingly, yes. It will also dissolve in dilute NaOH. It will also dissolve in dilute HCl. Those who've got the last 3 boxes correct, I want you to give yourselves double the points, 6 points. 2 for each right answer. The simple reason being, it's so very obvious, but still I say it to make my job complete at the moment. If a compound is water soluble, all the other solutions, be it HCl or bicarbonate, have been made in water. Therefore, the solubility will continue, not because of the bicarbonate, but because of the water content. So this is an area which has to be done carefully. Wait with your water test tube, the test tube where you've done the water test. Wait, see if it surely dissolves or not dissolves. Then only move on to the next warning. I hope you take a notice of that. Inferences from the table. What are the aliphatic compounds? What are the aromatic compounds? What are the halogen-containing compounds? What is the water-soluble acidic phenolic basic neutral? Borrowing my answers from there, aliphatic compounds are urea, chloroform, ethyl acetate. Aromatic compounds is this big chunk. X-containing are just 2. Water-soluble is urea. Acidic is this. Phenolic is this. Please excuse the up and down of the squares. 4-aminotoluene is basic, and the rest are neutral. Focus on the extreme right-hand side 4 compounds. Urea, benzoic acid, 2-naphthol, 4-aminotoluene, right? If I can assume now that based on this solubility alone, I've already got the name of the compound matching. I've already discovered that this compound, number so-and-so, is benzoic acid because it is dissolving in saturated bicarbonate. And therefore, for the given compounds 1 to 10, the probable results are compounds identified, these 4. So I've got 40% of the spotting done, right? So it leaves me with 6 more. 60% is a huge balance to be still worked with. But 4, I'm very, very, very sure about. I've used all my information and knowledge and understanding to apply those particular things together. Fine. Now I'm bringing in, you are provided with an assistant, like Alexa. What am I providing you with? Reagents, indicators, miscellaneous. Okay? So I have a table and I've categorized them, and I'm asking you to use these reagents in the minimum number of tests to identify the rest of the compounds. Okay? So, checklist, what do I have? And I'm asking you to use them in the minimum number of tests. You could have done 1,000 tests. I don't want that. I want you to optimize. I want you to economize. I want you to spend less time doing it, more time thinking about what to do. Okay? And I'm giving you some leads, no doubt. Steps to follow. Now, this is something which you'll imagine that you're doing on the basis of Beilstein's test, which you've already done, which you have identified. You've already put it down in the list. Separate chloroform, chlorobenzene from the rest. Which means I'm talking about 6 compounds. I've taken 2 aside because I've already known that in these 2 test tubes, I'm getting a green flame, right? And therefore, they are the halogenated compounds. The rest of the 4 are what we have, with unknown. Now, to those 2 test tubes that you have, one has chloroform, other one has chlorobenzene. I'm adding dilute NaOH and boiling it 2-3 minutes. I'm cooling it and add silver nitrate to the test tubes. They are halogen containing, to be specific, chloro containing. And I'm boiling it with sodium hydroxide. That is what I'm told to do. Remember it. Remember the theory. Figure it out. Cool and add silver nitrate to the test tubes. Okay? That's one test. Test number 1. I see that when I'm adding silver nitrate, a white precipitate is formed in one test tube. The other test tube does not have a white precipitate. Why? What is the solution to this? I've got the 2 compounds identified, but if you're able to match which test tube is chloroform, which test tube is chlorobenzene, it's the best thing that can happen. There is a reason, there is a way to match. I'm not asking you right now, but just take my word for it that you can do that. Okay? I'm now moving to the 3rd step. Step 1 and 2 have made me understand which is chloroform, which is chlorobenzene. For the balance 4 test tubes, I'm going to do the 2,4-DNP test, which we just take a few drops of the compound, add a few drops of 2,4-DNP, and check. Now, 2,4-DNP test, we have heard about it again from a very, very lower level of our graduation years, maybe even high school or plus 2 at least. And from there, we can identify benzaldehyde. So 4 test tubes, I'm adding drops of 2,4-DNP. In one test tube, I get a brilliant yellow precipitate formation. It is definitely the benzaldehyde. So I've managed to get 1 more of that 6. So 3 of those 6 compounds, which were not identified up to now, I'm able to do it with this assistance because I had these materials given to me. I had everything given to me. I've used some of them. Okay? Step number 4. So I have 3 test tubes. They are ethyl acetate, nitrobenzene, benzamide. I don't know which one is which. I'm taking them in 3 different test tubes, small amounts, adding distilled water, equal volume, adding dilute NaOH, maybe just a few drops, a drop of phenolphthalein, and boil. Before boiling, I obviously know that I have added sodium hydroxide and I've added phenolphthalein. My color has to be magenta pink, which is so typical. I have done this coloration so many times. It's pakka in my head. There's no missing that. Okay? I have started boiling again for 3 minutes, 4 minutes. I am checking the vapors with moist litmus paper as they are being expelled. So before boil, I need to keep moist litmus paper ready, which I've been supplied with. I may be supplied with blue, I may be supplied with red, I may be supplied with both, but I have to moisten it, right? And I'm able to identify benzamide. How? That's for you to think. But I'm telling you, from the vapors with moist litmus paper, benzamide can be identified, which leaves me with ethyl acetate, nitrobenzene. Observe the phenolphthalein color in the test tubes. It was pink. I boiled it. I have found benzamide because of the vapors. But what is happening to the test tube color? What is happening to all the test tube colors? I find, I'm telling you now, that one of the test tube colors has disappeared. And that is because ethyl acetate is identified. I'm telling you that one of the colors of ethyl acetate has disappeared. Therefore, I've identified ethyl acetate in that test tube. Which brings me to a reflection. I'm posing the question, you reflect. What has the role of dilute NaOH been in the tests that you have performed? Which tests am I talking about? I'm talking about the dilute NaOH, which cause the compound to dissolve. I'm talking about dilute NaOH, which cause the liberation of some gas, which helped me identify benzamide. I'm talking about the dilute NaOH used to check with silver nitrate what has happened to those halogenated systems. I'm talking about dilute NaOH also used to check my ester. So many roles it has played. I've not written them down, but there's enough food for you to reflect. Conclusion of this exercise, and I really hope you've been with me, probably identified, underlined, bold. Benzaldehyde, benzamide, chlorobenzene, etc., etc. So 9 of them. Not identified is nitrobenzene. Why did I say probably identified? Because confirmation is still required. What is my confirmation? My confirmation will be the melting point. If it was a solid, I've never even talked about the state. It'll be boiling point if it's a liquid. But today, if I'm able to, I can even do the spectral analysis. There's so much of spectroscopy that I can use, especially the PG labs will have access to it. I can do a lot, but I have to confirm. All right? Summary of my whole presentation is, identification of organic compound requires keen observation. You cannot do things mechanically. You cannot overlook any kind of observation, which is what the earlier speakers also insisted on. You've got to have appropriate logical inferences. You cannot be illogical. You've got to be rational. You've got to think in a particular direction. Now what? Now what? Now what? Why is this? Why is this not? Let me tackle this right now. So the questioning and the thinking and the speculation and the observation go on. What do I need to understand? I need to understand structures thoroughly. So when I say a name, I've got to visualize the structure and vice versa. I've got to understand the test that I'm performing. I'm going back to that metallic sodium. Why was metallic sodium used to test an alcoholic functional group? Why is that specific? What is happening? Do I understand the test? Can I apply to all alcohols? What would be the difference between a lower alcohol and a higher alcohol? Can I think of aromatic alcohols only if they are somewhere in the side chain and there's an aromatic nucleus somewhere? I can probably bring both those characteristics. But an OH on an aromatic nucleus is a phenol. It's not an alcohol, okay? So I need to understand the test to be performed. And I need to know functional group chemistry. The essence of organic spotting is ultimately going to be picking and choosing what is my functional group, what is the characteristic test for the functional group, what if this was a functional group. There are some tests which are kind of overlapping. The first thing that comes to mind is you must have heard of oil of wintergreen, right? You must have heard of iodex. And definitely that is related to two different classes of compounds. Just to make it complete, one is an aromatic acid, one is an ester, and one is an alcohol, and the two combined gives you an ester. So you can use it for CT of the acid, you can use it for CT of the ester, and it goes on and goes on and goes on, okay? Thank you for patiently listening to my presentation. I may have exceeded, yes I did. I'm sorry, Amrit, but yeah, but
It was our pleasure listening to you.
Thank you so much. Thank you so much. If
you
have
for delivering such a wonderful lecture. We have enjoyed every moment of your presentation. And ma'am, I'm honestly saying that this particular, this type of lecture can define a web workshop. Because in a workshop like this, we need to interact with the participants.
Right.
This should not be the one-sided delivery. So, ma'am, it was a wonderful learning experience for a junior teacher like me. Please accept my regards.
Come on, Amrit, you're not just a mere teacher. You're an enthusiastic teacher and a motivated teacher. So that's a really, really good quality to possess. Has anybody scored? If they have, then they can they just write down what the scoring is? Or if not now, then later on. Okay, so just for curiosity, I think there were about 98 points to score, almost like a 100-mark objective paper it has been. So when you take the responses of the assignments, maybe you can, ask them to scribble down. Or if they haven't done it, they can still do it, whatever. That's their choice. Any questions offhand? Maybe I can just take one.
Any questions from the participants? Any question? The forum is now open for questions. No question, ma'am.
Oh, good. All right. But still, in any case, if they do have, then I've given you my, put my email ID in the first slide.
Yes, definitely. Yeah. I shall share with you.
Yeah. Okay. Thank you so much, Amrit, for giving me this platform.
Oh, ma'am. It was our pleasure to have you amongst our mates.
Thank you. I can see Dr. Prabhu there. Good afternoon. Good evening, Dr. Prabhu.
Yeah. Yes. Actually, now we are beginning with the valedictory session.
Yeah. And I've delayed the start.
No, ma'am. No problem. No, ma'am. It was our pleasure, ma'am.
Thank you so much. Thank you. I shall remain for your felicitation or closure ceremony. Yeah. Thank you. God bless you. God bless all the participants.
Thank you. May I now request Professor D.V. Prabhu sir, the General Secretary of ACP, to deliver the secretarial address. Sir, we missed you very much on 16th. Over to you, sir. Sir, you are not audible. Am I audible? Okay. Prabhu sir, are you there? Professor DV Prabhu sir? Sir, can you hear us? Sir? Sir, can you hear us? Sir, you are not audible. Okay, before sir join, may I now request our respected principal sir, Professor Shantanu Chakraborty sir, to deliver the vote of thanks. Sir, please. Principal sir, are you there? Can anyone please confirm if there is any problem from my end?
No, yes, it is audible. Yes, Dr. Mitra, it is audible.
Okay, sir. Professor Prabhu sir, can you hear us? Sir, can you hear us?
I think he has some problem from his side.
Yes, ma'am.
শুনতে পাচ্ছ কি?
Yes, sir. Now it is audible, sir.
Can you hear me?
Yes, sir.
Yes, sir.
Oh, he's not able to hear.
Principal sir, can you please deliver the official vote of thanks? Respected principal sir. Principal sir, can you hear us?
Dr. Mitra, can't hear anything.
Oh, yes, sir. Sir, you are now audible. Prabhu sir, you are now audible.
Hello? Can you hear me?
Yes, sir. I think there is some problem with the Prabhu sir's internet connection. Can we please request our respected principal sir to deliver the official vote of thanks? Sir, can you hear us? Principal sir. Principal sir is also unable due to some network problem. The same problem is with Prabhu sir. Yes, sir. Yes, sir. We can't hear you, sir. Sir, will you try to rejoin? Principal, sir. So, in the meantime, may I now request Dr. Bonkim Ghosh, sir, to address the august audience about the norms of the workshop. Bonkim, sir, please.
Thank you, Professor Mukro. Am I audible?
Yes, sir. Loud and clear.
Good evening to all. It is really great day that day 3 and last day of this national level chemistry orientation program turned out to be very successful. First of all, I would like to thank the speaker, Professor Prabodh Choube, former Senior General Manager and Head R&D Center, BSF India, and former Chief Mentor, Innovation Hub, Nehru Science Center, and Professor Gulshan Sheikh, Associate Professor and ex-Vice Principal, St. Xavier's College, Mumbai, who shared their precious knowledge with all of us. It is really intelligent and thankful. I also want to thank our Principal Sir, Professor Shantanu Chakraborty, Government General Degree College, Singur, and Vice Chancellor Sir, Professor Ashutosh Ghosh, Rani Rasmani Green University, for taking effort to make this national level chemistry orientation program possible and contacting and promoting with other colleges and universities for participation. Thank you so much, all the audience, for paying your valuable attention and sharing with your opinion. Those participants who submitted the assignment of each day with proper time, they will get e-certificate through mail. Today's assignment link and feedback form uploaded in both Google Meet and YouTube. Finally, on behalf of Department of Chemistry, a Government General Degree College, Singur, I would like to thank Association of Chemistry Teachers to give the platform for such orientation program. Especially, we are thankful to Professor Brijesh Pare, President of ACT, and Professor D. Damodar V. Prabhu, Sir, General Secretary of ACT. Thank you all.
Thank you, sir. Thank you, sir. Principal, sir, can you hear us? Respected Principal, sir. Professor Prabhu, sir. Principal, sir, can you please try to unmute yourself? Okay, sir. Okay, sir. Okay, sir. Actually, Pare, sir, is also unable to join due to some urgency. So, I am delivering the vote of thanks on behalf of Principal, sir, and our respected General Secretary, Professor D.V. Prabhu, sir. Actually, this workshop wouldn't have been possible without the constant support and guidance of Professor Ashutosh Ghosh, sir, the Honorable Vice Chancellor of Rani Rashmani Green University, Professor Shantanu Chakraborty sir, Principal of Singur Government College, Professor D.V. Prabhu sir, General Secretary ACT, and Professor Brijesh Pare sir, the President of ACT. It is because of their relentless endeavor to make this program happen that we have been able to materialize it. I am very much thankful to all the resource personnel, respected Professor N. Satyamurthy sir, Dr. Prabodh Chobe sir, Professor Shumona Datta madam, Professor Niraja Dashaputre madam, Professor Unuka Kumbhar madam, and Professor Gulshan Sheikh madam for accepting my request to deliver lecture for this particular workshop. I am sincerely thankful to Professor Shoikat Bandyopadhyay for all the technical support he has provided in spite of his busy schedule. Thank you, Professor Shoikat Bandyopadhyay sir, for your valuable time. I am also very much indebted to all the faculty members of the Department of Chemistry, Dr. Monohar Mondol, Dr. Alokesh Hajari, Professor Joyashree Sadhuka, Dr. Bankim Ghosh, Dr. Ramkrishna Pramanik, Dr. Shubhendu Maiti for extending their support towards this particular workshop. My sincere thanks to Professor Subhash Prasad Singh sir, Secretary ACT East Zone, and Professor Prem Mohan Mishra sir, the Vice President of ACT East Zone, and Dr. Chaitali Chaudhary madam, IQAC Coordinator of Singur Government College, for being present in this particular workshop amidst your busy schedule. We had near about 1,500 registrations all over the country. The objective of this particular orientation workshop was to ignite the spirit of chemistry education among the students. We shall be glad if a few students have really been benefited through this particular workshop. Assignment link for today has been shared, as well as feedback form link. Hopefully, those of you who have regularly submitted the assignments and have filled the feedback form will be awarded with a certificate within 7 to 8 days. ACT, Department of Chemistry, Singur Government College, and Rani Rashmani Green University are deeply committed towards chemistry education, and we promise to arrange more such workshops for the benefit of the student fraternity. Please do take care of yourself, and hopefully we will meet soon. That's all for the day. Thank you. Best wishes and regards.
Thank you, Dr. Amrit Mitra.
Thank you, madam.
Very well organized workshop.
Thank you, madam. Please accept
Yes.
my regards.
Thank you.
Actually, I am very much indebted to all of you.
It was our
Gulshan
pleasure.
madam, you, Niraja madam, Satyamurthy sir,
No, it was our
Shumona
pleasure.
madam,
Yes.
Prabodh Chobe sir. Thank you for your support, madam.
You are welcome.
You're most welcome,
Amazing.
Amrit. You've done a very good job in
Very good job.
organizing
Thank you.
and getting students together on this platform.
Yes, ma'am, and undoubtedly it was a wonderful experience for the teacher participants also.
Yes, yes,
Because
yes.
through your presentation, Anupa madam's presentation, and through the presentation of other resource personnel, we have also learned so many things.
Correct. But then now you should keep doing it. I think your students will
Yes.
want some more. And if you're ready to give some more, then do it for them.
Yes, ma'am.
All
I
the
always
best.
need your guidance and support. Please guide me.
It'll be there. Don't worry. And all the best.
Thank you. Thank you. Thank you, Principal sir. Thank you, Professor Prabhu sir. Thank you, all the respected dignitaries present over here. Thank you all.
Yes, thank you, Amrit, and I will be now leaving the meeting.
Okay,
Yeah.
ma'am. Thank
Yes.
you, ma'am. Thank you.
Thank you, Amrit. So I'll
Thank you.
also leave the meeting.
Okay, ma'am.
All
Thank
right.
you.
Take care. Regards
Thank
to
you.
you. Thank you.
Okay.